The Milky Way is moving through space faster than you think. It might feel like we're sitting still on Earth, but in reality our entire galaxy is racing through space at an incredible speed. The Milky Way is moving at roughly 2.1 million kilometers per hour through the universe. That's so fast, it's hard to imagine. For comparison, a commercial airplane travels about 900 kilometers per hour, which means the Milky Way is moving more than 2,000 times faster than a jet plane. Even more surprising is that everything inside the galaxy moves along with it. Our Sun, Earth, and every star you see in the night sky are all passengers on this enormous cosmic journey. But we don't feel this motion because everything around us is moving together. It's similar to sitting inside a smooth train ride. Even if the train is speeding across the country, it feels calm inside because you and everything around you share the same motion. So right now, without noticing it, you are traveling through the universe at millions of kilometers per hour. For a long time, astronomers believed the universe contained about 100 to 200 billion galaxies. That already sounded unimaginably huge, but newer observations from powerful space telescopes revealed something even more astonishing. The universe may actually contain around 2 trillion galaxies. To picture this number, imagine every grain of sand on a large beach representing one galaxy. Even then, you might still be underestimating the true number scattered across the cosmos. Astronomers discovered this by studying tiny patches of the sky with deep space telescopes. In areas that looked completely empty, they found thousands of distant galaxies packed into a space no larger than a grain of rice held at arm's length. This means that almost every dark spot in the night sky hides entire galaxies filled with billions or trillions of stars. What looks empty to our eyes is actually crowded with cosmic structures beyond imagination. The universe is about 13.8 billion years old, but galaxies did not take very long to appear. Some of the earliest galaxies formed only a few 100 million years after the Big Bang. In cosmic terms, that is incredibly fast. If the entire age of the universe were compressed into a 24-hour day, the first galaxies would appear just minutes after midnight. These early galaxies were very different from the large, well-organized galaxies we see today. They were usually small, messy, and chaotic, filled with intense bursts of star formation. Gas clouds were collapsing quickly under gravity, creating new stars at an incredible pace. Astronomers detect these ancient galaxies by looking extremely far into space. Because light takes time to travel, observing them is like looking billions of years into the past. The faint light we see today began its journey when the universe was still very young. Galaxies are not randomly scattered across the universe. Instead, gravity pulls them together into enormous groups called galaxy clusters. A single cluster can contain hundreds or even thousands of galaxies bound together by gravity. But the structure does not stop there. Clusters themselves gather into even larger formations, called superclusters. These superclusters stretch across hundreds of millions of light years, forming some of the largest known structures in the universe. To picture this, imagine individual stars as houses, galaxies as cities, clusters as countries, and superclusters as entire continents spread across space. Our own Milky Way belongs to a group called the Local Group, which contains more than 50 galaxies. This group is part of a much larger region known as the Virgo supercluster. When astronomers map these massive structures, they see that galaxies form a huge cosmic web, with clusters and superclusters connected across unimaginable distances. In some galaxies, stars are being created at an incredible pace. These galaxies are known as starburst galaxies because they experience intense bursts of star formation. Instead of forming a few stars at a time like the Milky Way, they can produce hundreds or even thousands of new stars every year. For comparison, our galaxy creates only about 1 to 3 new stars each year. That means a starburst galaxy can form stars hundreds of times faster. This happens when huge clouds of gas become compressed. often after galaxies collide or pass close to each other. The pressure triggers massive regions where new stars ignite almost all at once. Imagine a quiet town suddenly turning into a giant construction site, where thousands of houses are built at the same time. That is similar to what occurs inside a starburst galaxy. These star factories shine extremely bright because young stars are hot, massive, and full of energy. Some galaxies display one of the most beautiful patterns in the universe. Perfect spiral arms gracefully winding around a bright center. These galaxies look like giant cosmic pinwheels spinning slowly in space. The spiral arms are not solid structures, but regions where stars, gas, and dust gather more densely. Inside these arms, new stars are constantly forming. Huge clouds of gas collapse under gravity, lighting up the spiral arms with clusters of bright young stars. This is why the arms often glow with blue and white light. Our own Milky Way is a spiral galaxy, although we cannot easily see its full shape because we are inside it. To imagine the scale, picture a spinning pinwheel that is 100,000 light-years wide, filled with billions of stars instead of paper blades. Each spiral arm can stretch across tens of thousands of light-years, slowly rotating around the galaxy's center over hundreds of millions of years. As we move forward, feel free to share where you're listening from or leave a quick thought below. And if this channel means something to you, subscribing is a small way to support the journey. Galaxy clusters are enormous regions of space, where hundreds or even thousands of galaxies are held together by gravity. Normally, the gravity of the cluster keeps its member galaxies moving around the center, like bees buzzing around a hive. However, in rare cases, some galaxies move so fast that they actually escape the cluster completely. These are sometimes called runaway or hypervelocity galaxies. Their incredible speed often comes from powerful gravitational interactions. For example, when galaxies pass very close to each other or interact with massive black holes, they can receive a huge gravitational slingshot that sends them flying outward. To imagine this, think about swinging a ball on a string and suddenly letting go. The ball shoots away in a straight line. A similar effect can happen in space. Some of these escaping galaxies travel millions of kilometers per hour, eventually leaving their galaxy cluster behind and drifting into the vast emptiness between clusters. On the largest scale, galaxies are not scattered randomly across space. Instead, they are connected by enormous invisible structures made mostly of dark matter. These structures form long threads called filaments, stretching across vast distances in the universe. These filaments act like cosmic highways where galaxies gather and travel. Gravity from the dark matter pulls gas and galaxies along these strands, guiding where galaxies form and cluster together. To imagine this structure, picture a giant spiderweb spread across space. The threads of the web represent the dark matter filaments, while the dew drops sitting on the threads represent galaxies and galaxy clusters. Some of these filaments stretch across hundreds of millions of light years, making them among the largest known structures in existence. Even though we cannot see the dark matter itself, astronomers can map these filaments by observing how galaxies align and move along these invisible cosmic pathways. Not all galaxies keep creating new stars forever. In some galaxies, star formation can suddenly slow down or stop completely. Astronomers sometimes describe these galaxies as becoming quiet or inactive because no new generations of stars are forming. Stars are born from large clouds of gas. If that gas disappears or becomes too hot and spread out, the galaxy can no longer produce new stars. Over time, the existing stars simply grow older without replacements. Imagine a factory that once produced thousands of products every day, but suddenly ran out of raw materials. The machines are still there, but nothing new can be made. Some galaxies stop forming stars after powerful events such as galaxy collisions, strong stellar winds, or activity from a supermassive black hole. These events can blow away or heat the gas needed for starbirth, Eventually, the galaxy becomes filled mostly with older, cooler stars, giving it a reddish appearance. Not all galaxies shine mainly in visible light. Some galaxies release enormous amounts of energy in the form of radio waves, which are a type of invisible radiation. These are called radio galaxies, and they can produce vast regions of radio energy that stretch far beyond the visible part of the galaxy. The source of this energy is usually a supermassive black hole at the galaxy's center. As gas and dust spiral into the black hole, powerful jets of charged particles shoot outward into space. These particles interact with magnetic fields and produce strong radio signals. To imagine the scale, picture a small lighthouse on an island, sending beams of light that stretch across an entire ocean. In radio galaxies, the energy beams can extend millions of light years into space. Even though our eyes cannot see radio waves, giant radio telescopes on Earth can detect these signals, revealing huge structures that are often much larger than the galaxy itself. When astronomers observe galaxies, the color of the galaxy can reveal important clues about the age of its stars. Some galaxies appear mostly red or orange, and this usually means the stars inside them are very old. Young stars tend to burn extremely hot and glow blue or white, but as stars age, they cool slightly and shine more red or yellow. Over billions of years, if a galaxy stops forming new stars, the bright blue stars gradually disappear. What remains are mostly older, cooler stars that give the galaxy a reddish glow. You can think of it like a campfire. When the fire is first burning strongly, the flames are bright and energetic. Later, when the fire settles down, glowing red embers remain. Many large elliptical galaxies look red because they stopped forming stars long ago. These galaxies are often called red and dead, meaning they contain mostly ancient stars and very little new star formation. Galaxy clusters are some of the heaviest structures in the universe. The largest clusters can contain a total mass equal to quadrillions of suns. A quadrillion means 1 million billion, which is an almost unimaginable amount of matter gathered in one place. This mass comes from many sources. A cluster may contain thousands of galaxies, enormous clouds of extremely hot gas, and vast amounts of invisible dark matter. In fact, dark matter usually makes up most of the cluster's total weight. To picture this scale, imagine weighing every star in thousands of galaxies at the same time. Even then, you would still need to include huge amounts of hidden dark matter surrounding the cluster. Some giant clusters stretch across tens of millions of light years. That means light itself would take millions of years just to travel from one side of the cluster to the other, showing how massive and enormous these cosmic structures truly are. At the centers of many galaxies lie supermassive black holes, but some galaxies host even more extreme versions known as ultramassive black holes. These giants can weigh billions of times more than our Sun. That means their gravity is so strong that they control the motion of vast numbers of stars near the galaxy's center. To picture this scale, imagine squeezing the mass of several billion suns into a region not much larger than our solar system. The gravity there would be so powerful that anything wandering too close, gas, dust, or even stars, could be pulled inward. As material falls toward the black hole, it forms a swirling disk that becomes incredibly hot and bright. This region can release enormous energy across space. Some of the largest known black holes sit inside giant galaxies at the centers of galaxy clusters, acting like massive anchors influencing the behavior of their entire galaxy. In many galaxy clusters, one galaxy stands out as the largest and most dominant. These are usually giant elliptical galaxies, and they often sit right at the center of the cluster, where gravity is strongest. These central galaxies are enormous. Some contain trillions of stars and stretch across hundreds of thousands, or even millions of light years. Over billions of years, they grow by pulling in and absorbing smaller galaxies that drift too close. You can imagine the cluster like a busy city square, with many smaller buildings surrounding one massive skyscraper in the middle. That skyscraper represents the giant central galaxy. Because of their location, these galaxies are surrounded by huge clouds of hot gas and dark matter. Their powerful gravity helps hold the entire cluster together. Many astronomers believe these central giants are the end result of countless galaxy mergers happening over billions of years. Not all galaxies keep their original shapes. Some look twisted, stretched, or bent, and this usually happens because of gravitational interactions with nearby galaxies. When galaxies pass close to each other, their powerful gravity can pull on each other's stars, gas, and dust. These gravitational forces can distort spiral arms, stretch galaxies into long shapes, or even pull streams of stars far into space. Sometimes galaxies end up looking like they have tails, bridges, or warped disks. Imagine two large balls of soft dough drifting close together. As they pull on each other, the dough stretches and changes shape. In space, gravity creates similar effects on entire galaxies. Some distorted galaxies show long streams of stars, stretching hundreds of thousands of light years away from their original position. By studying these unusual shapes, astronomers can learn about past encounters and collisions between galaxies that happened millions or billions of years ago. While some galaxies have stopped making new stars, others are filled with active regions where stars are constantly being born. These galaxies contain large amounts of cold gas and dust, which serve as the raw materials for star formation. Inside these galaxies, giant clouds of gas collapse under gravity and form clusters of young stars. Many of these newborn stars are very hot and bright, giving the galaxy a blue or white glow. Imagine a massive construction site where new buildings are rising everywhere at the same time. In a similar way, these galaxies are constantly adding new stars across their spiral arms and gas clouds. Some star-forming galaxies can create dozens or even hundreds of stars each year, much faster than the Milky Way, which forms only a few annually. Over millions of years, this steady activity fills the galaxy with new generations of stars and planetary systems. Not all galaxies shine mainly in visible light. Some galaxies produce extremely strong ultraviolet radiation, which is a type of light with much higher energy than what our eyes can see. This radiation usually comes from very hot young stars that burn at extremely high temperatures. Massive young stars can glow intensely in ultraviolet light because their surfaces are far hotter than stars like our Sun. These stars are often found in regions where new stars are forming rapidly. Imagine turning on thousands of extremely bright blue-white lamps all at once. The combined glow would be incredibly intense. In galaxies, large groups of young stars can create similar bursts of ultraviolet energy. Some of these UV-bright regions can stretch across thousands of light years, lighting up entire sections of the galaxy. Astronomers use special telescopes designed to detect ultraviolet light to study these regions and learn where new stars are actively forming. When astronomers observe extremely distant galaxies, they are actually seeing ancient light that began traveling billions of years ago. Because light takes time to move across space, looking far away also means looking far back in time. Some galaxies are so distant that their light started its journey over 13 billion years ago, when the universe was still very young. During all that time, the light continued moving through space until it finally reached our telescopes. To picture this, imagine sending a message across a vast ocean that takes thousands of years to arrive. By the time it reaches its destination, the world may look completely different. The same idea applies to light traveling across the universe. This means that when astronomers observe these distant galaxies today, they are seeing them as they existed billions of years in the past, allowing scientists to study the early stages of galaxy formation and cosmic history. When the Milky Way and Andromeda eventually merge billions of years from now, the final result will likely look very different from the spiral galaxies we see today. Scientists believe the combined galaxy may become a giant elliptical galaxy, which is a rounded system of stars without clear spiral arms. During the merger, the orderly rotation of stars in both galaxies will become disturbed. Gravity will fling stars in many different directions, mixing their paths together. Over time, the smooth spiral patterns will fade away. Imagine two spinning pinwheels crashing into each other. The original blades would lose their shape and become a large, scattered cloud of pieces. A galaxy merger can produce a similar transformation. The new galaxy could contain hundreds of billions or even trillions of stars, spread across hundreds of thousands of light years. Instead of spiral arms, it would appear as a large glowing oval or sphere of stars, slowly rotating through space. Inside giant molecular clouds, gravity slowly begins pulling gas and dust together. Over time, certain regions inside the cloud become denser and heavier, forming compact clumps of material. As these clumps continue collapsing under their own gravity, the pressure and temperature at the center start to rise. Eventually, the core becomes so hot and dense that nuclear fusion ignites, marking the birth of a new star. At that moment, hydrogen atoms begin fusing together and releasing enormous energy. The newly formed star then starts shining. You can imagine this process like a snowball rolling down a hill. As it rolls, it gathers more snow and grows larger. In a similar way, the collapsing gas gathers more material until it becomes a star. This process can take hundreds of thousands to millions of years. But a single molecular cloud can form hundreds or even thousands of stars, gradually building new star clusters inside a galaxy. In recent years, astronomers have discovered strange signals coming from distant galaxies called fast radio bursts, often shortened to FRBs. These bursts are incredibly brief flashes of radio energy that last only a few thousandths of a second. Yet they release an enormous amount of power. In that tiny moment, a single fast radio burst can release as much energy as the sun produces in several days. Even though the signal is extremely short, it can still be detected across billions of light years of space. Imagine a camera flash going off for just a split second, but bright enough to be seen from another continent. Fast radio bursts behave in a similar way, except they occur in distant galaxies. Astronomers are still studying what causes them. Some may come from highly magnetized neutron stars called magnetars, while others might involve extreme cosmic events happening deep inside distant galaxies. Our galaxy, the Milky Way, is surrounded by many smaller companion galaxies, known as satellite galaxies. Astronomers have already discovered dozens of these satellites, and new ones are still being found as telescopes improve. Most of these satellites are dwarf galaxies, meaning they are much smaller than the Milky Way and contain far fewer stars. Some may hold only a few million stars, compared to the Milky Way's more than 100 billion. These small galaxies orbit the Milky Way at distances of tens to hundreds of thousands of light years. Two of the most famous examples are the Large Magellanic Cloud and the Small Magellanic Cloud, which can even be seen from the southern hemisphere with the naked eye. You can imagine the Milky Way as a giant city surrounded by many smaller towns moving around it. Over time, gravity may slowly pull some of these satellite galaxies closer until they are eventually absorbed into our galaxy. When astronomers map millions of galaxies across space, they discover that the universe has a remarkable pattern called the cosmic web. Instead of being evenly spread out, galaxies gather along enormous filaments that form a vast network across the universe. These filaments connect galaxy clusters, like threads in a giant three-dimensional web. Between the threads are enormous empty regions called cosmic voids, where very few galaxies exist. To picture this structure, imagine looking closely at a sponge or a piece of foam. The material forms a network of walls and strands, while the empty spaces sit in between. On the scale of the universe, galaxies and clusters form the walls, while the vast empty spaces lie between them. Some parts of this web stretch across hundreds of millions of light years. Mapping this structure helps astronomers understand how gravity slowly shaped matter into the large cosmic patterns we observe today. In some galaxies, certain areas suddenly begin forming stars at an extremely rapid rate. These areas are known as starburst regions. Inside them, enormous clouds of gas collapse quickly, producing huge clusters of new stars in a relatively short time. A single starburst region can contain thousands or even millions of newly forming stars, packed into a space only a few hundred light years across. These newborn stars are very hot and bright, causing the region to glow intensely. To imagine this, think of a quiet forest where suddenly thousands of fireworks ignite. All at once, the sudden burst of light would make the entire area glow brightly. Starburst regions behave in a similar way, but across enormous cosmic distances. These regions often appear after galaxy collisions or close encounters, which compress large clouds of gas. As a result, the galaxy briefly becomes a powerful factory for producing new stars across its spiral arms and gas clouds. At the heart of every quasar lies an incredibly powerful engine, a supermassive black hole. These black holes can contain millions or even billions of times the mass of our Sun, and their immense gravity pulls in nearby gas and dust. As this material spirals toward the black hole, it forms a rapidly spinning structure called an accretion disk. Friction and gravity heat this disk to extreme temperatures, causing it to glow with enormous energy. This glowing disk is what produces the brilliant light of a quasar. To imagine how powerful this process is, think of water rushing down a drain. As it spirals inward, the motion becomes faster and more energetic. Around a supermassive black hole, the same idea happens with gas and dust, but on a cosmic scale. Even though the black hole itself is invisible, the intense energy from the surrounding material can make the quasar visible across billions of light years of space. When astronomers observe a spiral galaxy from the side, they call it an edge-on galaxy. From this angle, the galaxy's wide disk appears as a thin, glowing band of stars stretching across space, with a bright bulge at the center. This view reveals just how flat many spiral galaxies actually are. Even though a galaxy may be more than 100,000 light-years wide, the thickness of its stellar disk can be only a few thousand light-years. That means the galaxy is shaped somewhat like a giant cosmic pancake. Imagine looking at a dinner plate from the side. The plate is wide and round, but from that angle, it appears as a thin line. Spiral galaxies look similar when seen edge-on. Edge-on views also reveal dark dust lanes running across the disk. These dusty regions block light from stars behind them, creating dark stripes that show where gas and dust are concentrated inside the galaxy. The period known as the Cosmic Dark Ages lasted for hundreds of millions of years after the Big Bang. During this time, the universe had not yet formed stars or galaxies, so space was filled with darkness, a neutral hydrogen gas that blocked most light. As the first stars and galaxies began to appear, they released intense radiation into the surrounding space. This energy gradually ionized the hydrogen gas, meaning it stripped electrons away from the atoms and changed the state of the gas. You can imagine this process like sunlight slowly burning away a thick morning fog. At first, the fog blocks your view, but as the sunlight grows stronger, the fog clears and everything becomes visible. Over time, the radiation from countless early galaxies cleared the cosmic fog across huge regions of space. This event marked the end of the cosmic dark ages, allowing light to travel freely across the universe and making distant galaxies visible. The heavy elements created and spread by ancient stars do more than form planets. They also provide the basic ingredients needed for life. Elements such as carbon, oxygen, nitrogen, and iron are essential for building complex molecules, including the ones that make up living organisms. These elements were forged inside massive stars and later scattered across galaxies by supernova explosions. Over billions of years, this enriched material became part of new star systems, planets, oceans, and atmospheres. Imagine baking a cake without the right ingredients. The cake cannot exist. In the same way, life requires specific elements, and those elements were created long ago inside stars. This means that the atoms in your body, like the carbon in your cells and the iron in your blood, were once part of ancient stars that exploded billions of years ago. Because galaxies spread these elements throughout space, scientists believe that the ingredients for life may exist on many planets across the universe. Inside many galaxies are thick regions of cosmic dust, known as dust lanes. These dark bands often stretch across parts of the galaxy's disk and can block the light from stars behind them. In telescope images, they sometimes appear as long dark streaks, cutting across the bright glow of the galaxy. This dust is made of extremely tiny particles of carbon, silicon, and other elements floating through space. Even though each particle is microscopic, together they form huge clouds that can extend thousands of light years across. Imagine looking at a bright city through heavy smoke or fog. The lights are still there, but the smoke blocks part of your view. Dust lanes work in a similar way, hiding stars behind them. These dusty regions are also important because they contain the raw materials for future stars and planets, making them active areas where new stellar systems may eventually form. Galaxies do not only shine in the light our eyes can see, they also emit energy across many different wavelengths, including radio waves, infrared, ultraviolet, X-rays, and even gamma rays. Because of this, astronomers study galaxies using many different types of telescopes. Each wavelength reveals something different. Infrared light can pass through dust and show hidden stars. Radio waves can reveal clouds of gas and huge jets from black holes. X-rays often come from extremely hot gas or energetic objects like neutron stars and black holes. Imagine trying to understand a city using only one photograph. You might see the buildings but miss the roads, underground tunnels, or electrical systems. Using different wavelengths is like using multiple tools to explore every part of the city. By combining observations from many wavelengths, astronomers can build a much more complete picture of how galaxies form, evolve, and interact across the universe. When we look up at the night sky, the stars we see are only a tiny fraction of what exists inside a galaxy. Our own galaxy, the Milky Way, is already enormous, containing more than 100 billion stars. But some galaxies are far larger. The biggest ones can contain over 1 trillion stars. To picture this, imagine counting one star every second. Even if you counted non-stop day and night, it would take over 30,000 years just to reach 1 trillion. That shows how unbelievably massive these galaxies are. Many of these giant galaxies are called elliptical galaxies, and they often sit at the centers of galaxy clusters. They grew so large by slowly absorbing smaller galaxies over billions of years. So when astronomers say a galaxy contains 1 trillion stars, they are talking about a cosmic city of stars so huge that it makes our entire galaxy seem small in comparison. Galaxies are among the largest structures in the universe, and their size can be truly staggering. Many galaxies stretch across hundreds of thousands of light years, from one side to the other. A light year is the distance light travels in a year, which is about 9.5 trillion kilometers. Our own Milky Way is already enormous, measuring roughly 100,000 light years across. But some galaxies are far bigger. Certain giant galaxies can extend 300,000 to 500,000 light years wide, making them several times larger than our own galaxy. To imagine this scale, picture light racing around Earth 7 times in a single second. Even moving that fast, it would still take hundreds of thousands of years for that light to cross one of these gigantic galaxies. Inside that vast space are billions or even trillions of stars, along with planets, gas clouds, and dust. Each galaxy is essentially a massive island of stars floating in the dark ocean of space. While many galaxies gather in groups and clusters, some live in almost complete isolation. These are known as isolated galaxies, and they drift through deep space with very few neighbors nearby. In some cases, the nearest galaxy may be millions of light years away. To imagine this distance, think about cities on Earth. Most cities have nearby towns, highways, and busy regions around them, but an isolated galaxy is more like a single house standing alone in the middle of a vast desert, with no other buildings for thousands of miles. Because they have little interaction with other galaxies, isolated galaxies often evolve differently. They are not disturbed by collisions, tidal forces, or gravitational pulls from neighbors. This allows astronomers to study how galaxies grow without outside influence, almost like observing a natural experiment. These lonely galaxies remind us that the universe contains both crowded cosmic neighborhoods and incredibly empty regions of space. When we think about planets, we usually picture our own solar system. But planets are actually very common across galaxies. Since most stars are believed to have planets orbiting them, a single galaxy can contain billions or even trillions of planets. Take the Milky Way as an example. It contains over 100 billion stars, and many of those stars likely have multiple planets. This means our galaxy alone may contain hundreds of billions of planets. To imagine that number, think about every grain of sand on a long beach. Now imagine each grain representing a different planet somewhere in the galaxy. Some of these planets are gas giants, others are frozen worlds, and some may be rocky planets similar to Earth. Scientists believe that billions of them could exist in the habitable zone, where temperatures might allow liquid water to exist. This means the universe could be filled with countless worlds waiting to be discovered. In some galaxies, most of the mass does not come from stars at all. Instead, it comes from something invisible called dark matter. In these unusual galaxies, the stars we see may make up only a tiny fraction of the total mass, while dark matter forms the overwhelming majority. Astronomers discovered this by measuring how fast the stars move inside these galaxies. The stars travel much faster than they should if only visible matter were present. The only explanation is that a large amount of hidden mass is creating extra gravity. Imagine a small glowing lantern floating inside a giant invisible balloon. The lantern represents the stars, while the balloon represents the huge dark matter halo surrounding the galaxy. Some dwarf galaxies appear to be almost entirely controlled by dark matter, with very few stars compared to their total mass. Studying these galaxies helps scientists learn more about dark matter, one of the biggest mysteries in modern astronomy. Not all galaxies have beautiful spiral arms. Some look more like giant glowing balls of stars. These are called elliptical galaxies. Instead of a flat disk with spiral arms, the stars in these galaxies move in many different directions, creating a smooth, rounded shape. Elliptical galaxies can be small, but some are among the largest galaxies in the universe. The biggest ones can contain trillions of stars and stretch across hundreds of thousands or even millions of light years. To imagine one, picture a massive sphere made of countless stars packed together, like a glowing swarm of fireflies. Unlike spiral galaxies, elliptical galaxies usually contain very little gas or dust, which means they rarely form new stars. Many astronomers believe these galaxies formed after multiple galaxy collisions and mergers. Over billions of years, those violent encounters mixed the stars together, slowly erasing the original spiral structures and leaving behind a smooth, enormous ball of stars. Sometimes a galaxy becomes the stage for one of the most powerful explosions in the universe, a gamma-ray burst. These bursts release enormous amounts of energy in just a few seconds. In fact, a single gamma-ray burst can release more energy in a few seconds than our sun will produce during its entire 10 billion year lifetime. Most gamma-ray bursts happen when extremely massive stars collapse at the end of their lives. As the star's core collapses into a black hole, powerful jets of energy blast outward at nearly the speed of light. These jets shoot through space, producing intense gamma radiation. To imagine the scale, it would be like a single light bulb suddenly shining brighter than an entire city full of lights combined. Even though these bursts are extremely powerful, they usually happen billions of light years away, so they pose no danger to Earth. But astronomers carefully study them because they reveal dramatic events happening inside distant galaxies. Not all galaxies are easy to see with regular telescopes. Some galaxies are partially or completely hidden behind thick clouds of cosmic dust. This dust is made of tiny particles of carbon, silicon, and other elements floating between the stars. When visible light tries to pass through these dusty regions, much of it gets blocked or scattered. As a result, the galaxy behind the dust may appear very dim or even invisible in normal photographs of space. Imagine trying to look at a bright city through a heavy fog or thick smoke. The lights are still there, but the fog hides much of the view. Cosmic dust can do something similar on a much larger scale. Fortunately, astronomers can still study these hidden galaxies using infrared and radio telescopes, which can see through the dust more easily. These special observations often reveal galaxies filled with intense star formation, showing that some of the most active regions of the universe are hidden behind cosmic dust clouds. While some galaxies stop forming stars, others remain incredibly active and continue producing new stars for billions of years. These galaxies contain large supplies of cold gas, which is the main ingredient needed for star formation. Inside these galaxies, huge clouds of gas slowly collapse under gravity. As the gas becomes denser and hotter, it eventually ignites nuclear fusion, giving birth to new stars. This process happens again and again across different regions of the galaxy. Our own Milky Way is still forming stars today. On average, it creates about 1 to 3 new stars each year. That might not sound like much, but over millions of years it adds up to millions of new stars. To picture this, imagine a quiet construction site that never completely shuts down. Even if only a few buildings are constructed each year, the city slowly grows larger over time. In the same way, active galaxies continue expanding their populations of stars. Some radio galaxies create structures so enormous that they stretch millions of light years across space. These giant structures are formed by powerful jets of particles blasting out from the galaxy's central supermassive black hole. As the black hole pulls in gas and dust, part of the energy gets redirected into narrow beams that shoot outward in opposite directions. These jets travel at speeds close to the speed of light and push far beyond the galaxy itself. At the ends of these jets, huge clouds of energetic particles form giant radio lobes. These lobes glow strongly in radio wavelengths and can grow unbelievably large. To picture the scale, if one of these radio structures were placed over the Milky Way, it could stretch dozens of times wider than our entire galaxy. Some of the largest known radio galaxies reach 5 million light-years or more across, making them among the largest single objects ever observed in the universe. When astronomers see a galaxy glowing with a bluish color, it usually means that the galaxy is full of young, hot stars. These stars burn much hotter than older stars, which causes them to shine with bright blue or white light. Young stars are often very massive and energetic. However, they do not live very long compared to smaller stars. Some of these massive blue stars may burn out and explode in only a few million years, which is extremely short in cosmic time. Because of this, a blue galaxy is usually a sign that new stars are constantly being formed. The galaxy still has plenty of gas and dust available to create new generations of stars. You can imagine a blue galaxy like a busy construction site, where new buildings are constantly rising. The bright blue glow is the light from these newly formed stars lighting up the galaxy across tens of thousands of light years. Galaxies may seem isolated in space, but many are constantly affected by the gravity of nearby galaxies. Even when galaxies are millions of light years apart, their gravitational pull can slowly influence each other's motion and shape. Over long periods of time, this gravity can stretch galaxies, disturb their spiral arms, or pull streams of stars away from them. These interactions are often called gravitational encounters. They can dramatically change the structure of galaxies without the galaxies actually colliding. Imagine two large whirlpools in water drifting near each other. Even if they never fully merge, their spinning currents can still pull and distort the water around them. Some galaxies develop long tidal streams of stars, stretching hundreds of thousands of light years because of these gravitational effects. By studying these distortions, astronomers can learn about past encounters between galaxies and understand how gravity continues shaping the universe over billions of years. Some supermassive black holes do more than just pull matter inward. In certain galaxies, they launch powerful jets of particles that shoot out into space at speeds close to the speed of light. These jets form when gas and dust spiral toward the black hole, creating an extremely hot spinning disk. Strong magnetic fields near the black hole can redirect some of this energy into narrow beams that blast outward from the galaxy's center. These beams carry charged particles traveling hundreds of thousands of kilometers per second. To imagine this speed, light could travel around Earth about 7 times in 1 second. The particles in these jets move nearly that fast. These jets can stretch millions of light years across space, far beyond the galaxy that produced them. Along the way, they heat surrounding gas and influence the growth of entire galaxy clusters, showing how one black hole can affect enormous regions of the universe. The giant galaxies found at the centers of galaxy clusters did not start out so enormous. Over billions of years, they grew larger by absorbing smaller galaxies that drifted too close. This process is sometimes called galactic cannibalism, because the central galaxy sits in the region where gravity is strongest. Many nearby galaxies slowly fall toward it. As they approach, the massive gravity of the larger galaxy begins pulling them apart. Their stars spread out and eventually become part of the bigger galaxy. Imagine a snowball rolling down a snowy hill. As it moves, it picks up more snow and becomes larger and larger. In a similar way, central galaxies slowly grow as they collect smaller galaxies around them. Some of these giant galaxies may have swallowed hundreds of smaller galaxies during their lifetime. This long history of mergers is one reason they contain such huge numbers of stars. While the Milky Way contains more than 100 billion stars, some of the largest galaxies in the universe are far more massive. The biggest galaxies may contain several trillion stars, making them among the most crowded stellar systems ever discovered. These giant galaxies are usually found at the centers of galaxy clusters, where gravity pulls many galaxies together. Over billions of years, the central galaxy slowly absorbs smaller galaxies that drift too close. Each merger adds more stars, making the galaxy larger and brighter. To picture the scale, imagine counting one star every second. Even if you counted non-stop, it would take over 30,000 years just to reach 1 trillion. Some of these enormous galaxies can stretch hundreds of thousands or even millions of light years across. Inside them are vast numbers of star systems, nebulae, and possibly countless planets, making them some of the largest star-filled structures in the universe. Around certain galaxies, astronomers have discovered thousands of globular star clusters orbiting far beyond the main body of the galaxy. These clusters are dense groups of stars packed tightly together by gravity. A single globular cluster can contain hundreds of thousands to millions of stars, squeezed into a region only a few dozen light years across. If one of these clusters replaced the region around our sun, the night sky would appear filled with thousands of bright stars shining at once. Some giant galaxies host over 10,000 globular clusters, forming an enormous halo of star groups around them. For comparison, The Milky Way has about 150 known globular clusters, which is far fewer. These clusters are extremely ancient, many formed more than 10 billion years ago, making them among the oldest objects in a galaxy. Studying them helps astronomers understand the early history and formation of galaxies. While some galaxies glow strongly in ultraviolet light, others shine most brightly in infrared light, which is a type of radiation our eyes cannot see but we often associate with heat. Infrared light is especially useful for studying galaxies that contain large amounts of dust. Dust particles inside galaxies can block visible light, hiding many stars from normal telescopes. However, this dust absorbs energy and then re-emits it as infrared radiation. Because of this, galaxies filled with dust can appear faint in visible light, but incredibly bright in infrared. Imagine a thick fog hiding the lights of a city at night. Even though the lights are difficult to see, the city is still full of activity behind the fog. Infrared observations help astronomers see through that cosmic fog. Some infrared galaxies release more energy than hundreds of billions of suns combined, often because they contain intense star formation or active supermassive black holes hidden within dusty regions. Not all galaxies travel through space alone. Some galaxies exist in pairs, locked together by gravity and slowly orbiting one another. These systems are often called galaxy pairs or binary galaxies. Just like the Moon orbits Earth because of gravity, two nearby galaxies can circle each other across enormous distances. Their orbit can take hundreds of millions or even billions of years to complete. A well-known example is the Milky Way and the Large Magellanic Cloud, a smaller galaxy that orbits our own. Other galaxy pairs can be more evenly matched, with both galaxies slowly circling a shared center of gravity. Imagine two giant whirlpools in a lake slowly spinning around each other. Over time, their motion may bring them closer together. Eventually, many galaxy pairs begin to interact more strongly. Their gravity stretches their shapes, and after billions of years, the two galaxies may merge together to form a single larger galaxy. On the largest scale, the universe is built from galaxies. Instead of stars being scattered randomly through space, most of them gather together inside galaxies. These galaxies then group into clusters, superclusters, and enormous cosmic structures. You can think of galaxies as the basic building blocks that form the visible universe. Each galaxy contains huge collections of stars, gas, dust, and dark matter, all bound together by gravity. To picture this, imagine a vast country filled with cities. Each city contains millions or billions of people living together in one place. In the universe, galaxies play a similar role. They are the cosmic cities of stars. Some galaxies contain billions of stars, while others hold trillions. When astronomers map the universe, they find that these galaxies form a gigantic cosmic web, stretching across billions of light years. Without galaxies, the universe would be a far more empty and scattered place. Not every galaxy shines brightly in the sky. Some galaxies are extremely faint, making them very difficult for astronomers to detect. These galaxies contain relatively few stars spread across a large area, which means their light is very dim compared to more crowded galaxies. Even powerful telescopes sometimes struggle to see them because their glow blends into the darkness of space. In many cases, astronomers discover these galaxies only after carefully analyzing deep images of the sky. Imagine trying to see a few tiny candles glowing from miles away in a dark field. The light would be so faint that it might be easy to miss. Faint galaxies can be similar. Some of these galaxies are located hundreds of millions of light years away, while others exist closer but remain difficult to spot because of their weak brightness. Discovering them helps scientists understand the full variety of galaxies that exist across the universe. Fast radio bursts may last only a few milliseconds, but during that incredibly short moment, they release an astonishing amount of energy. In fact, a single burst can emit as much energy as the sun produces over several days or even weeks. To understand how brief this is, a millisecond is 1,000th of a second. That means these powerful bursts appear and disappear faster than the blink of an eye. Yet even from billions of light years away, radio telescopes on Earth can still detect them. Imagine a powerful lighthouse flashing once so brightly that ships thousands of kilometers away could see it instantly. A fast radio burst is somewhat similar, except the signal travels across the universe. Some galaxies have produced repeating bursts, meaning the same source sends out multiple flashes over time. These mysterious signals have become one of the most exciting discoveries in modern astronomy, and scientists are still working to understand exactly how they form. Many of the smallest galaxies in the universe are known as dwarf galaxies, and they are often found orbiting much larger galaxies. These dwarf galaxies contain far fewer stars, sometimes only a few million to a few billion, compared to the hundreds of billions found in large galaxies like the Milky Way. Because of their smaller mass, dwarf galaxies are strongly affected by the gravity of their larger neighbors. They can orbit around a large galaxy for billions of years, slowly circling it through space. Imagine a large planet surrounded by many small moons. The moons are pulled by the planet's gravity and move around it in steady orbits. In space, dwarf galaxies behave in a similar way around giant galaxies. Some dwarf galaxies travel hundreds of thousands of light years from their host galaxy during their orbit. Over time, however, the larger galaxy's gravity may eventually pull them closer, sometimes leading to their absorption. Within the vast cosmic web, galaxies are not spread out evenly along the filaments. Instead, they tend to gather at the points where several filaments intersect. These intersections become the densest regions in the universe and often grow into enormous galaxy clusters. Gravity plays the main role in this process. Matter slowly flows along the filaments like water moving through river channels. As gas, dark matter, and galaxies travel along these cosmic strands, they eventually pile up at the crossing points. Imagine highways from several directions meeting at a major city. Traffic naturally builds up at the intersection, where all the roads connect. In the universe, galaxy clusters form in a similar way, where cosmic filaments meet. Some of these intersection regions contain thousands of galaxies spread across tens of millions of light years. Studying these dense areas helps astronomers understand how galaxies gather and grow within the enormous structure of the cosmic web. Some galaxies are known as starburst galaxies because they produce new stars at an astonishing speed. In these galaxies, star formation happens far more rapidly than in normal galaxies like the Milky Way. Our galaxy forms about 1 to 3 new stars each year, but a starburst galaxy can create dozens, hundreds, or even thousands of stars every year. This intense activity often happens when huge clouds of gas become compressed, usually after galaxies collide or pass very close to each other. Imagine a quiet town suddenly turning into a massive construction zone where thousands of houses are built at the same time. That is similar to what happens in a starburst galaxy. These galaxies shine extremely bright because they are filled with young, hot stars. However, this intense star formation cannot last forever. Over time, the galaxy may run out of gas, causing the starburst phase to eventually slow down or stop. The supermassive black holes powering quasars can consume huge amounts of matter from their surroundings. Gas, dust, and even entire stars may be pulled toward the black hole if they drift too close. As this material spirals inward, it forms a bright swirling disk that feeds the black hole. In some active galaxies, these black holes can swallow material equal to several suns every year. That may not sound fast, but considering the size of a star like the Sun, it represents an enormous amount of matter disappearing into the black hole. Imagine a giant whirlpool in the ocean, pulling in everything floating nearby. In space, the black hole acts like that whirlpool, drawing material inward through gravity. While much of the matter falls into the black hole, some of it gets heated and blasted outward in powerful jets and radiation, spreading energy across millions of light years around the galaxy. When astronomers view a spiral galaxy from above, they call it a face-on galaxy. From this angle, the galaxy's full structure becomes visible, revealing its sweeping spiral arms winding outward from the bright center. These spiral arms can stretch tens of thousands of light years across the galaxy. They often glow brightly because they contain many young stars, glowing nebulae, and large clouds of gas where new stars are forming. Imagine looking down at a giant spinning pinwheel. From above, you can clearly see each blade curving outward from the center. A face-on spiral galaxy looks very similar, with its arms creating beautiful swirling patterns across space. This viewpoint allows astronomers to study how stars, gas, and dust are arranged throughout the galaxy. By observing these spiral patterns, scientists can better understand how galaxies rotate and how star formation spreads through their spiral arms over time. Inside certain galaxies, especially those with active star formation, astronomers have discovered extremely massive stars. These stars can be tens or even hundreds of times more massive than our Sun. Because of their enormous mass, they burn fuel incredibly fast and shine with intense brightness. These giant stars are much hotter than stars like our Sun. Their surfaces can reach temperatures of tens of thousands of degrees, causing them to glow with brilliant blue or white light. To imagine their scale, think of our Sun as a typical campfire. A massive star would be more like a blazing industrial furnace, producing vastly more energy and light. However, these stars do not live long. While the Sun may shine for about 10 billion years, extremely massive stars may live only a few million years before they explode as powerful supernovae, spreading heavy elements across their galaxy. Astronomers now believe that our galaxy may contain billions of planets, similar in size to Earth. Thanks to modern planet-hunting missions, scientists have discovered that planets are extremely common around stars. Many stars appear to host entire planetary systems, since the Milky Way contains more than 100 billion stars. Even a small percentage having Earth-sized planets would still result in billions of potentially Earth-like worlds across our galaxy. To imagine this number, think of every grain of sand on a long beach representing a different planet, orbiting a distant star. Some of these planets may orbit in the habitable zone, the region around a star where temperatures could allow liquid water to exist on the surface. Water is considered one of the key ingredients for life. This means our galaxy alone may contain countless worlds where conditions could potentially support oceans, atmospheres, and perhaps even life. The thick dust clouds inside galaxies can hide enormous numbers of stars from view. When light from stars travels through these clouds, much of it gets absorbed or scattered by the dust particles. As a result, entire regions of a galaxy can appear dark even though many stars are actually there. Imagine trying to see a bright city skyline through a dense fog. The buildings and lights are still present, but the fog blocks much of the light, making parts of the city look dim or invisible. In some galaxies, these dusty regions stretch across thousands of light years, hiding vast numbers of stars behind them. Our own Milky Way contains thick dust clouds that block our view of the galaxy's center in visible light. Because of this, astronomers often use infrared telescopes, which can see through much of the dust. These instruments reveal hidden stars, glowing gas clouds, and star-forming regions that would otherwise remain concealed behind cosmic dust. When astronomers observe a galaxy using different wavelengths of light, they often discover completely different features within the same galaxy. Each wavelength highlights a different part of the galaxy's structure. For example, visible light mainly shows the stars that shine across the galaxy. Infrared light can reveal hidden stars and warm dust clouds that are invisible in normal images. Radio waves often show enormous clouds of hydrogen gas, or giant jets from supermassive black holes. Meanwhile, X-rays can reveal extremely hot gas and powerful energetic events. Imagine studying a large city using different types of maps. One map might show roads, another might show underground subway systems, and another might show electrical networks. Each map reveals something different about the same place. In the same way, observing galaxies across multiple wavelengths allows astronomers to uncover layers of activity and structure that would remain hidden if they looked at only one type of light. At the heart of most galaxies lies something incredibly powerful, a supermassive black hole. These black holes are not small objects like the ones formed from dying stars. Instead, they can contain millions or even billions of times the mass of our Sun. The Milky Way itself has one called Sagittarius A. Even though it is about 26,000 light-years away, its gravity controls the motion of many nearby stars. Some of these stars race around it at millions of kilometers per hour. To picture how strong this gravity is, imagine something with the mass of 4 million suns squeezed into a region smaller than our solar system. Its gravity is so intense that not even light can escape once it gets too close. Despite their terrifying nature, these black holes may actually help galaxies stay organized. Their gravity influences the motion of stars and gas, shaping the entire galaxy around them. When galaxies pass close to each other or collide, gravity begins to pull on their stars like an invisible tug of war. This powerful gravitational stretching can create huge streams of stars and gas called tidal tails. These tails can extend hundreds of thousands of light years into space, sometimes longer than the galaxy itself. Imagine two spinning clouds of glitter slowly brushing past each other. As they interact, long glowing strands would stretch outward. That's similar to what happens during a galactic encounter. These tidal tails are filled with stars that were pulled away from their original galaxy by gravity. Some of them may even form new star clusters along the tail. To visualize the size, if one of these tails stretched across our solar system, it would extend far beyond the orbit of Pluto and keep going for thousands of times that distance. They are some of the most beautiful and dramatic structures astronomers observe in space. Some galaxies are so enormous that their size is almost impossible to imagine. The largest known galaxies can stretch millions of light years from one side to the other. That makes them dozens of times wider than our own Milky Way. One famous example is the giant galaxy IC 1101, which is estimated to be about 5 to 6 million light years across. To understand that scale, remember that the Milky Way is about 100,000 light years wide. This means IC 1101 could be 50 times larger than our entire galaxy. If our solar system sat near the center of such a giant galaxy, light would take millions of years just to travel from one edge to the other. These colossal galaxies usually form in crowded regions of space, where many smaller galaxies collide and merge over billions of years, slowly building one of the largest structures found anywhere in the universe. Our galaxy may look calm in the night sky, but its past is surprisingly dramatic. The Milky Way has already swallowed several smaller galaxies over billions of years. These smaller companions are called dwarf galaxies, and they contain far fewer stars than large galaxies like ours. As a dwarf galaxy drifts too close, the Milky Way's powerful gravity begins pulling it apart. Its stars stretch into long streams that slowly wrap around our galaxy. Over time, those stars blend in with the Milky Way, becoming part of its structure. Astronomers have actually discovered these stellar streams, long trails of stars that are the leftover remains of galaxies our Milky Way consumed long ago. To picture it, imagine pouring a small stream of glitter into a spinning bowl. Eventually, the glitter spreads out and becomes part of the swirl. Scientists believe the Milky Way will continue absorbing dwarf galaxies in the future. As it slowly grows larger, some galaxies contain incredibly powerful engines at their centers that can launch enormous jets of energy into space. These jets are created by supermassive black holes that are actively pulling in large amounts of gas and dust. As this material spirals inward, part of it gets blasted outward at extremely high speeds, The result is two narrow beams of energy shooting out in opposite directions from the galaxy's center. These jets travel at nearly the speed of light and can stretch millions of light years into space. To imagine the scale, if one of these jets started in the Milky Way, it could extend far beyond our galaxy and continue across the distance between several galaxies. These jets glow in radio waves and X-rays, making them visible to powerful telescopes. They can also heat surrounding gas and influence the growth of entire galaxy clusters, showing how one black hole can affect regions of space far beyond its galaxy. Many galaxies are not made of just individual stars. Surrounding them are large groups of stars known as star clusters. A single galaxy can be surrounded by hundreds or even thousands of these clusters, forming a halo of tightly packed stars orbiting around the galaxy. One common type is called a globular cluster. These clusters contain hundreds of thousands or even millions of stars packed closely together. Imagine a glowing ball made of countless stars gathered into a space only a few dozen light years wide. The Milky Way itself is surrounded by more than 150 known globular clusters, and astronomers believe there may be many more still hidden or too faint to detect. To picture their size, if one globular cluster replaced the region around our Sun, the night sky would appear incredibly crowded, with thousands of bright stars visible at once. These clusters are some of the oldest structures in galaxies, often more than 10 billion years old. Dark matter is believed to make up most of the mass in typical galaxies. In many cases, it forms a massive invisible halo surrounding the visible stars. However, astronomers have discovered a few surprising galaxies that appear to contain very little dark matter at all. This discovery puzzled scientists because dark matter is thought to play a major role in forming galaxies. Without its extra gravity, galaxies should have difficulty holding themselves together. These unusual galaxies still contain billions of stars, yet their movements suggest that the invisible mass normally expected is missing. It's like finding a large building that seems to be standing without the heavy support beams normally required. To picture the difference, imagine most galaxies as icebergs, where most of the mass is hidden below the surface. These rare galaxies, however, appear to be almost all visible and very little hidden. Studying them helps scientists better understand how galaxies and dark matter actually work. Galaxies rarely exist completely alone. Many gather together into enormous groups called galaxy clusters. These clusters can contain hundreds or even thousands of galaxies, all held together by the pull of gravity. To imagine the scale, picture galaxies as glowing cities in space. Galaxy cluster would be like a vast metropolitan region filled with thousands of these star cities, spread across millions of light years. One well-known example is the Coma cluster, which contains over 1,000 galaxies packed into a region about 20 million light years wide. That distance is so large that light itself takes 20 million years just across the cluster. Between the galaxies inside these clusters is extremely hot gas that glows in X-rays, along with huge amounts of invisible dark matter holding everything together. Galaxy clusters are some of the largest gravitationally bound structures in the universe, giving astronomers important clues about how matter is distributed across cosmic space. When astronomers discover a galaxy with two cores, it usually tells a story about something dramatic that happened in the past. Dual cores are often strong evidence that two galaxies collided and began merging together. When galaxies crash into each other, their stars rarely collide directly because the distances between stars are enormous. Instead, the galaxies pass through one another while gravity slowly pulls them together. During this process, the original centers of both galaxies can remain visible as two bright cores inside the newly forming galaxy. Imagine two cities slowly blending together over time. At first, both downtown areas still exist, so the new combined city temporarily has two centers of activity. These double cores can remain visible for millions or even billions of years before finally merging into one. By studying these systems, astronomers can reconstruct the history of galactic collisions and better understand how many large galaxies formed through repeated mergers. The beautiful spiral arms seen in many galaxies are not just decorative patterns, they are actually active regions where new stars are constantly being born. These arms contain large amounts of gas and dust, the essential ingredients needed to form stars. As the galaxy rotates, waves of gravity move through the disk like slow-moving traffic jams. When gas clouds pass through these regions, they become compressed. This compression causes the gas to collapse and ignite, creating new stars and star clusters. You can imagine this like cars bunching up on a busy highway. The traffic slows and gathers in certain areas. In spiral galaxies, gas gathers in the spiral arms, making them perfect places for star formation. Because many of the stars formed there are young, hot, and bright. The spiral arms often glow with blue and white light. Some arms stretch tens of thousands of light years long, making them some of the most striking structures in the universe. Not all galaxies have a simple circular center. In many galaxies, including the Milky Way, the stars near the center form a long structure called a stellar bar. This bar looks like a bright, straight line of stars stretching across the middle of the galaxy. These bars can be enormous. In some galaxies, they extend tens of thousands of light years from one side of the center to the other. That distance is comparable to traveling across a large portion of the entire galaxy. Imagine a spinning pinwheel with a glowing stick running through the middle. The spiral arms then curve outward from the ends of that stick. That is roughly how a barred spiral galaxy appears. Astronomers believe these bars help move gas toward the center of the galaxy. This flowing gas can trigger new star formation and may even feed the supermassive black hole at the galaxy's core. The first galaxies that formed in the early universe were surprisingly small and tightly packed compared to many galaxies we see today. These early galaxies were extremely compact, meaning their stars were squeezed into a much smaller region of space. Some of these young galaxies contained billions of stars, yet they were only a few thousand light years across. For comparison, the Milky Way spreads across about 100,000 light years, making it far larger. Imagine taking a huge city and compressing it into the space of a small town. Everything would be crowded together. That is similar to how dense these early galaxies were. Astronomers believe that over billions of years, many of these compact galaxies grew larger through mergers and star formation. As galaxies collided and absorbed smaller neighbors, their stars spread out over wider areas. Studying these compact galaxies helps scientists understand how the first galaxies in the universe began to grow. Not all light from galaxies is visible to our eyes. Some galaxies shine strongly in X-rays, a very energetic type of radiation. This X-ray glow usually comes from extremely hot gas trapped inside the galaxy or around it. This gas can reach temperatures of millions of degrees, far hotter than the surface of our Sun, which is about 5,500 degrees Celsius. At such extreme temperatures, the gas becomes so energetic that it releases powerful X-rays. To imagine this heat, think of metal glowing red when heated in a furnace. Now imagine gas heated thousands of times hotter than that. Astronomers use special space telescopes designed to detect X-rays because Earth's atmosphere blocks them. These observations reveal huge halos of hot gas surrounding some galaxies and galaxy clusters. Studying this glowing gas helps scientists understand how galaxies grow and how energy from black holes spreads throughout their surroundings. One of the most dramatic ways a galaxy can change shape is when another galaxy passes directly through its center. When this happens, the gravitational shock pushes stars and gas outward, creating a large expanding ring. Think of it like punching a hole through the middle of a spinning disk of water. The disturbance sends waves racing outward in a circular pattern. In space, the same thing can happen on a much larger scale when galaxies interact. As the ring spreads outward, it compresses gas clouds along its edge. This compression often triggers intense star formation, causing the ring to glow brightly with young stars. Some of these rings can grow over 100,000 light-years wide, roughly the size of the Milky Way. One famous example is the Cartwheel Galaxy, which looks like a giant glowing wheel floating in space, with bright star clusters forming along its expanding ring. The powerful stellar winds produced inside some galaxies can be so strong that they push gas completely out of the galaxy itself. This process is sometimes called a galactic outflow. When massive stars explode as supernovae or release intense radiation, they inject huge amounts of energy into the surrounding gas. If enough energy builds up, the gas gets heated and accelerated until it escapes the galaxy's gravity. These outflows can carry enormous amounts of material far into space. Imagine a powerful gust of wind blowing dust out of a valley and into the open sky. In galaxies, the same idea happens, but on a far larger scale. Some galactic winds travel at thousands of kilometers per second and can push gas tens or even hundreds of thousands of light years away. When this gas leaves the galaxy, it reduces the material available to form new stars, which can slow down future star formation. Around some galaxies, astronomers have discovered long, faint streams of stars stretching far into space. These stellar streams are usually the remains of smaller galaxies that were pulled apart and absorbed by a larger galaxy. When a small galaxy drifts too close, the stronger gravity of the larger galaxy begins tearing it apart. Its stars get stretched into long ribbons that wrap around the galaxy like glowing trails. Imagine stirring a drop of cream into a cup of coffee. At first, you see thin streaks swirling through the liquid. Over time, those streaks spread out and blend in. Stellar streams behave in a similar way, except the process takes millions or billions of years. Some of these streams can extend hundreds of thousands of light years across space. Astronomers study them carefully because they reveal the hidden history of galaxy mergers that shaped the galaxy we see today. The universe is about 13.8 billion years old, but some galaxies appeared surprisingly early in cosmic history. Astronomers have discovered galaxies that already existed when the universe was less than 1 billion years old. That means these galaxies formed when the universe was still in its early stages. To imagine this timing, picture the entire history of the universe as a 24-hour day. In that comparison, these early galaxies would appear within the first hour after midnight. During this time, the universe was much smaller, denser, and filled with clouds of gas. Gravity quickly pulled this gas together, forming the first stars and small galaxies. These early galaxies were often compact and chaotic, filled with intense star formation. Scientists detect them by observing extremely distant regions of space. Because light takes time to travel, seeing these galaxies means we are looking billions of years back in time, witnessing some of the universe's earliest cosmic structures. When galaxies merge, the event can completely reshape their structure and appearance. Over time, the graceful spiral arms or organized shapes of the original galaxies may disappear, replaced by a new form created by the combined stars and gas. During a merger, gravity pulls stars into long arcs and streams that stretch across space. Gas clouds collide and compress, often triggering intense bursts of star formation. These events can fill the merging system with clusters of bright young stars. Imagine two massive storms swirling together in the ocean. As they merge, their original patterns vanish, and a new, larger storm forms. A galaxy merger behaves in a similar way, but across hundreds of thousands of light years. These mergers are one of the main ways galaxies grow and evolve. Over billions of years, repeated mergers can transform spiral galaxies into giant, elliptical galaxies, helping shape the large structures we observe throughout the universe today. Inside many galaxies are gigantic clouds of gas and dust, known as nebulae. These nebulae act as stellar nurseries, where new stars are born. Some of these clouds are truly enormous, stretching across dozens or even hundreds of light years. Within a nebula, Gravity slowly pulls gas and dust together into dense regions. As these clumps grow heavier, pressure and temperature rise until nuclear fusion begins, igniting a brand new star. You can imagine a nebula like a massive cosmic nursery, where thousands of stars are forming at the same time. If one of these clouds replaced the region around our solar system, it would extend far beyond the orbit of Pluto, many thousands of times over. One famous example is the Orion Nebula, where hundreds of young stars are forming right now. Across many galaxies, these glowing nebulae light up spiral arms and star-forming regions with beautiful clouds of color and energy. One of the strangest things about ultra-diffuse galaxies is that some of them are almost as large as the Milky Way. Even though they contain far fewer stars, their stars are spread out across enormous distances, giving the galaxy a very faint and ghostly appearance. Some ultra-diffuse galaxies stretch across tens of thousands of light years, similar to the size of many normal galaxies. However, because their stars are scattered so widely, the galaxy's overall brightness is extremely low. Imagine a large city where the buildings are separated by vast empty fields. The city might cover a huge area, but from far away it would look quiet and dim because the lights are spread out. Astronomers were surprised when they first discovered these galaxies because they challenge our understanding of how galaxies form. Despite their faint appearance, some ultra-diffuse galaxies still contain large amounts of dark matter holding their stars together. In some galaxies, astronomers have discovered enormous curved structures made of stars called stellar arcs. These arcs look like giant glowing crescents stretching across parts of the galaxy. Stellar arcs usually form when gravity disturbs the galaxy, often during close encounters with other galaxies. The gravitational pull can stretch groups of stars into long, curved shapes that slowly move through the galaxy over time. Imagine swinging a bucket of water in a circular motion. As the water moves, it forms curved streams along the edge of the bucket. In space, gravity can create similar sweeping arcs of stars, but on a far larger scale. Some stellar arcs extend tens of thousands of light years across, making them larger than many entire galaxies. These structures help astronomers trace past gravitational events, revealing when galaxies were pulled or disturbed by nearby neighbors millions or billions of years ago. On the largest scale, the universe forms a huge network known as the cosmic web. In this web, galaxy clusters are connected by long thread-like structures called cosmic filaments. These filaments are made of galaxies, gas, and vast amounts of invisible dark matter. Some of these filaments stretch across hundreds of millions of light years, linking massive clusters together across enormous distances. Along these filaments, gravity slowly pulls galaxies and gas toward dense regions where clusters grow. To picture this structure, imagine a giant three-dimensional spiderweb floating through space. The threads represent the filaments, and the places where several threads meet are where large galaxy clusters form. Even though the galaxies themselves are separated by huge distances, this cosmic web creates a kind of large-scale structure for the universe. By mapping these filaments, astronomers can see how matter has gathered and organized itself over billions of years of cosmic evolution. Although cosmic voids are mostly empty, they are not completely devoid of galaxies. A small number of void galaxies exist within these vast regions. These galaxies live far away from the crowded clusters and filaments where most galaxies gather. Because they are so isolated, void galaxies experience very little gravitational disturbance from neighboring galaxies. This makes them interesting to astronomers, since their evolution can be studied without the usual effects of galaxy collisions or close encounters. Imagine a single house standing alone in the middle of a huge desert, far away from cities or towns. Void galaxies are similar, existing in regions where the nearest galaxy might be tens of millions of light years away. Some of these galaxies continue forming stars quietly for billions of years. By studying them, scientists can better understand how galaxies behave when they grow in extreme isolation within the universe's largest empty spaces. At the centers of some galaxies are incredibly bright objects called quasars. A quasar forms when a supermassive black hole is actively pulling in huge amounts of gas and dust. As this material spirals toward the black hole, it forms a hot, glowing disk that releases enormous energy. This energy can be so powerful that a quasar may shine brighter than the entire galaxy around it. Even though the glowing region around the black hole might be smaller than our solar system, it can produce light visible from billions of light years away. Imagine a single lighthouse so bright that it outshines an entire city at night. That gives an idea of how intense a quasar can be. Quasars were among the first extremely distant objects discovered by astronomers. By studying them, scientists can learn about the behavior of supermassive black holes and the early growth of galaxies in the young universe. One of the most remarkable things about quasars is how far their light can travel. Because quasars are so incredibly bright, their light can cross billions of light years of space before reaching Earth. Some quasars we observe today are more than 12 billion light years away. That means the light we detect began its journey when the universe was still very young. In many cases, the light started traveling long before our solar system or even Earth existed. To imagine this distance, remember that light moves at about 300,000 kilometers per second. Even at that incredible speed, it still takes billions of years for the light from these distant quasars to arrive here. Observing these objects is like receiving a message sent across cosmic time. By studying quasar light, astronomers can learn what the universe looked like billions of years ago, revealing details about early galaxies and black holes. Not all galaxies maintain a neat and symmetrical appearance. Some galaxies look messy, distorted, and chaotic, especially after they have experienced collisions or close encounters with other galaxies. These interactions can dramatically disturb the galaxy's structure. When galaxies pass near each other, their powerful gravity pulls on stars, gas, and dust. Spiral arms may stretch into long streams. Stars may scatter into unusual patterns, and gas clouds may be compressed or torn apart. The result can be a galaxy that looks twisted or irregular. Imagine two large clouds of colored smoke drifting together and mixing. As they collide, the original shapes disappear and swirl into a chaotic pattern. Something similar can happen when galaxies interact. Some of these distorted galaxies show long tidal tails stretching hundreds of thousands of light years into space. By studying these unusual shapes, astronomers can learn about past galactic collisions that occurred millions or billions of years ago. When massive stars explode as supernovae, they do more than just create a spectacular flash of light. These explosions also scatter huge amounts of heavy elements into the surrounding galaxy. Elements such as carbon, oxygen, iron, and calcium are blasted outward at incredible speeds. These materials were originally created deep inside the star during its lifetime. When the supernova occurs, the explosion throws those elements across space, enriching nearby gas clouds. Imagine a giant dandelion puff being blown apart by the wind. Its seeds scatter in every direction and eventually land far away. In a similar way, a supernova spreads heavy elements across thousands of light years of space. Over time, this enriched material mixes with gas clouds that will later form new stars and planets. Without supernova explosions distributing these elements, many of the building blocks needed for rocky planets and complex chemistry would not exist throughout galaxies. Galaxies act as enormous cosmic environments where stars and planetary systems can form and evolve. Inside galaxies are vast clouds of gas and dust, which serve as the raw materials for creating new stars. When parts of these clouds collapse under gravity, a new star is born. Around many young stars, a spinning disk of leftover gas and dust forms. Over time, tiny particles in this disk collide and stick together, gradually building larger objects These growing clumps eventually form planets, moons, asteroids, and comets. You can imagine this process like flour swirling in a mixing bowl. As the ingredients gather and clump together, larger pieces begin to form. In space, gravity plays the role of the mixer. Because galaxies contain billions of stars and vast amounts of gas, they provide the perfect conditions for countless planetary systems to form, shaping the cosmic neighborhoods where planets and possibly life can exist. Not all galaxies are easy to see with ordinary telescopes. Some galaxies appear almost invisible in visible light, even though they may contain large amounts of gas, dust, and stars. This happens because thick dust clouds inside the galaxy block much of the light that would normally reach our eyes. When astronomers observe these galaxies with standard optical telescopes, they may appear as faint shadows or barely detectable smudges in the sky. Imagine trying to look at a bright city through a thick sandstorm. Even though the buildings and lights are still there, the swirling dust makes the city difficult to see. However, these galaxies are not truly invisible. When astronomers observe them using infrared or radio telescopes, the hidden structures become much clearer. These wavelengths can pass through the dust, revealing active star-forming regions and large clouds of gas that were previously hidden from view. One major way galaxies grow larger over time is through continuous mergers with other galaxies. When two galaxies move close together, gravity slowly pulls them toward each other. Eventually they may collide and merge into a single larger galaxy. This process happens over hundreds of millions or even billions of years. During the merger, stars from both galaxies mix together, while gas clouds collide and often trigger bursts of new star formation. You can imagine this like two small towns gradually expanding until they connect and form one larger city. Over time, the boundaries disappear and everything becomes part of a single community. Astronomers believe many large galaxies we see today, including the Milky Way, grew by absorbing smaller galaxies throughout their history. Each merger adds more stars, gas, and dark matter, slowly building larger and more massive galaxies across hundreds of thousands of light years of space. Galaxies may look calm and peaceful in pictures, but across the universe, they are constantly drifting into one another. These galactic collisions are happening everywhere, although they unfold extremely slowly. A single collision between galaxies can take hundreds of millions to billions of years to fully complete. Imagine two massive clouds of stars, gas and dust, slowly passing through each other. Because the distance between stars is so huge, actual star-to-star crashes are very rare. It's like two swarms of tiny insects flying through each other, without many direct hits. Instead, gravity pulls the galaxies apart and stretches them into strange shapes. Long streams of stars can be pulled out like glowing ribbons across space. In fact, our own galaxy will eventually experience this. The Milky Way is predicted to collide with the Andromeda Galaxy in about 4 to 5 billion years, creating an entirely new galaxy. Most galaxies shine because of the billions of stars inside them, but some galaxies are so incredibly bright that they can outshine entire groups of neighboring galaxies. These extremely luminous galaxies are often powered by intense activity near their centers. At the core of these galaxies sits a supermassive black hole feeding on huge amounts of gas and dust. As this material spirals inward, it heats up to extreme temperatures and releases enormous energy. The result is a galaxy that can shine hundreds or even thousands of times brighter than a normal galaxy. To imagine this brightness, think about a city seen from space at night. Now imagine one single building glowing brighter than the entire city around it. That's similar to what astronomers observe when one powerful galaxy dominates the light of an entire region of space. These brilliant galaxies can be seen from billions of light years away, making them some of the brightest objects in the universe. Some galaxies are so incredibly massive that their gravity can actually bend light itself. This strange effect is called gravitational lensing. When light from a distant galaxy travels toward Earth, it may pass near a very massive galaxy along the way. The gravity of that galaxy curves the path of the light, almost like a cosmic magnifying glass. Imagine placing a clear glass marble on top of a piece of paper with writing. The words behind the marble appear stretched or curved. A massive galaxy can do something similar to the light from objects behind it. Sometimes this bending creates arcs, rings, or multiple images of the same distant galaxy. In some cases, a single background galaxy appears duplicated several times around the foreground galaxy. This effect is extremely useful for astronomers. It helps them study galaxies that would normally be too faint or too far away to see clearly, revealing hidden parts of the universe. Galaxies are not always peaceful neighbors. Sometimes a large galaxy slowly pulls in and absorbs a smaller galaxy through gravity. This process is often called galactic cannibalism. When a smaller galaxy drifts too close, the powerful gravity of the larger galaxy begins to stretch it apart. Its stars, gas, and dust get pulled away and gradually spread into the bigger galaxy. Over time, the smaller galaxy completely disappears as its material becomes part of the larger one. Imagine a giant whirlpool in water, pulling in smaller floating objects. Once they get too close, they are slowly drawn inward and mixed into the spinning flow. This process can take hundreds of millions or even billions of years to finish. During that time, long streams of stars may appear stretching through space. Many of the largest galaxies in the universe grew to their enormous size by absorbing countless smaller galaxies throughout cosmic history. The first galaxies in the universe looked nothing like the large, beautiful galaxies we see today. When the universe was very young, the earliest galaxies were tiny, messy, and chaotic. Instead of smooth spiral shapes or giant elliptical structures, they were more like clumps of gas and young stars forming rapidly. These early galaxies often contained only a few million to a few billion stars, which is small compared to the Milky Way's more than 100 billion stars. Think of them as the baby versions of modern galaxies. Inside these young galaxies, huge clouds of gas were collapsing under gravity and forming stars at a fast rate. Exploding stars and powerful radiation made these galaxies turbulent and unstable. Imagine a growing city that is still under construction everywhere. Buildings rising quickly, streets unfinished, and activity happening all at once. Over billions of years, these small chaotic galaxies merged and grew, eventually forming the massive galaxies we see across the universe today. Not every galaxy fits neatly into a spiral or elliptical shape. Some galaxies look messy and uneven, with no clear pattern or structure. These are called irregular galaxies. Instead of smooth arms or round shapes, they often appear like scattered clouds of stars, gas, and dust. Irregular galaxies can look as if something disturbed them. In many cases, that is exactly what happened. Nearby galaxies may have pulled on them with gravity, stretching and twisting their structure. Past collisions or close encounters can leave them looking chaotic. Imagine a carefully arranged sandcastle suddenly hit by a strong wave. The original shape disappears, leaving an uneven pile of sand. Irregular galaxies are somewhat similar, except the sand is made of billions of stars. Some irregular galaxies are tens of thousands of light years wide, still enormous compared to our solar system. Despite their messy appearance, many of them contain active star-forming regions where new stars are constantly being born. Some galaxies are so massive that their gravity can bend the path of light traveling through space. This strange effect is known as gravitational lensing. When light from a distant galaxy passes near a massive foreground galaxy, the powerful gravity of that galaxy curves the light's path before it reaches us. The result can look incredible through telescopes. Astronomers sometimes see stretched arcs, glowing rings, or multiple copies of the same galaxy appearing around the foreground galaxy. A simple way to imagine this is by placing a clear drinking glass on top of a newspaper. The letters behind the glass appear curved or distorted. A massive galaxy acts like a giant cosmic lens doing the same thing to light. Some of these lenses are so powerful they allow astronomers to see galaxies that are billions of light years farther away, acting like natural magnifying glasses, built by gravity itself. Some galaxies are so incredibly luminous that they dominate the brightness of the entire region around them. These galaxies can shine hundreds of times brighter than typical galaxies, making them visible from extremely far away in the universe. Much of this brightness comes from intense activity happening inside the galaxy. Massive bursts of star formation or powerful energy from a supermassive black hole at the center can release enormous amounts of light and radiation. To imagine this, think of a dark countryside at night, with many small towns scattered around. Now imagine one massive city whose lights are so bright that it outshines all the surrounding towns combined. That is similar to how these galaxies appear in space. Because they are so bright, astronomers can detect them from billions of light years away. Their intense glow helps scientists study the distant universe and understand how galaxies grow and evolve over cosmic time. Most galaxies have a single center where stars are packed more tightly together, but astronomers have discovered that some galaxies contain two galactic cores instead of one. These double centers often appear as two bright regions close to each other inside the same galaxy. This unusual structure usually forms when two galaxies merge together. Each galaxy originally had its own center, often containing a supermassive black hole. When the galaxies collide and combine, their cores do not immediately blend together. Instead, they can remain separate for a long time while slowly moving closer. Imagine two glowing campfires placed near each other in a dark field. From a distance, you would see two bright points instead of one. That is similar to how a double-core galaxy can appear through telescopes. Over millions or billions of years, gravity gradually pulls these cores together. Eventually, they may merge into one larger galactic center. In certain galaxies, the outer stars move at astonishing speeds as they orbit the galaxy's center. These stars can travel hundreds of kilometers every second, which means they complete enormous journeys around the galaxy over millions of years. To understand how fast that is, imagine driving a car around Earth's equator. At highway speed, it would take several days, but some stars in fast-rotating galaxies move so quickly that they could circle Earth in just a few minutes. At these extreme speeds, you might expect the stars at the outer edge to fly away into space. Surprisingly, they remain bound to the galaxy. The reason is the powerful gravitational pull created by both visible matter and the galaxy's massive dark matter halo. Without that extra hidden gravity, many of those fast-moving stars would escape entirely. Studying these rapid rotations has helped astronomers understand just how much unseen dark matter surrounds galaxies. Inside the spiral arms of the Milky Way, there are enormous regions where new stars are constantly being born. Astronomers often call these regions star nurseries. They are made of huge clouds of gas and dust, known as nebulae, which can stretch across dozens or even hundreds of light years. Within these clouds, gravity slowly pulls gas together into dense clumps. As the clumps grow heavier, the pressure and temperature rise until nuclear fusion begins, creating a brand new star. You can imagine a star nursery like a giant cosmic greenhouse, where many new stars are growing at the same time. Some of these regions contain hundreds or even thousands of forming stars. One famous example in our galaxy is the Orion Nebula, a bright star-forming region about 1,300 light-years away. It is so active that new stars are being born there right now as we observe it from Earth. When galaxies pass close to each other, their powerful gravity can stretch and distort one another. This effect is known as tidal forces. Instead of staying perfectly round or spiral-shaped, the galaxy can become elongated, warped, or pulled into strange shapes. The same type of force happens on Earth between the Moon and the oceans, creating tides. In space, however, The forces act on entire galaxies instead of water. Imagine two balls of soft clay slowly drifting close together. As they pull on each other, the clay stretches and forms long strands. Something similar happens when galaxies interact. These tidal forces can pull stars and gas outward into long tidal streams that may extend hundreds of thousands of light years into space. Some of these streams eventually form new star clusters, or even small new galaxies. By observing these stretched structures, astronomers can trace past gravitational encounters between galaxies. The powerful jets launched from some galaxies do not stop at the edge of the galaxy. Instead, they can travel far beyond the galaxy's visible boundaries, reaching deep into intergalactic space. In many cases, these jets stretch for millions of light years. To understand how far that is, remember that the Milky Way is about 100,000 light years wide. Some jets extend distances that are 10 to 50 times larger than an entire galaxy. Imagine a powerful fire hose spraying water so strongly that the stream travels far beyond the building it came from and continues across an entire city. In space, these jets behave in a similar way, but on an unimaginable scale. As the jets push through space, they inflate giant glowing regions called radio lobes at their ends. These enormous structures reveal just how much energy a supermassive black hole can release into the surrounding universe. In some rare cases, galaxies can develop giant rings of stars after a dramatic encounter with another galaxy. This usually happens when a smaller galaxy passes directly through the center of a larger one. The gravitational shock from this impact sends a powerful wave outward through the galaxy's disk. As this wave moves through clouds of gas and dust, it compresses the material and triggers intense star formation along the expanding edge. The result is a glowing ring filled with clusters of newly formed stars. A good way to imagine this is dropping a stone into a calm pond. The splash sends circular ripples spreading outward across the water. In a galaxy, the ripple is made of stars and gas instead of water. These rings can grow to be hundreds of thousands of light years across, sometimes larger than the Milky Way itself. They are among the most unusual and striking galaxy shapes astronomers observe. Inside some galaxies, powerful streams of gas known as stellar winds can blow outward into space. These winds are created by huge numbers of massive stars, releasing energy and material into their surroundings. When many of these stars are active at the same time, their combined energy can push enormous amounts of gas across the galaxy. These winds often occur in starburst galaxies, where new stars are forming very quickly. The intense radiation and explosions from massive stars act like giant cosmic blowtorches, pushing gas outward at incredible speeds. To picture this, imagine thousands of powerful fans all blowing in the same direction. The combined force would push air strongly across a room. In a galaxy, the same idea happens, but with vast clouds of gas moving through space. Some stellar winds can travel thousands of kilometers per second and stretch tens of thousands of light years, shaping the galaxy's future by redistributing gas needed for new star formation. When we look at a galaxy through a telescope, we usually see its bright disk filled with stars. But a galaxy actually extends far beyond what we can easily see. Surrounding many galaxies is a vast region called the galactic halo, which stretches deep into space. This halo can contain old stars, globular star clusters, hot gas, and enormous amounts of dark matter. In many cases, the halo reaches several times farther than the visible galaxy itself. For example, the Milky Way's bright disk is about 100,000 light years wide, but its halo may extend hundreds of thousands of light years into space. That means the galaxy's true size is much larger than it first appears. You can imagine a glowing lantern surrounded by a huge invisible cloud. The lantern represents the visible stars, while the halo forms a massive outer region that quietly surrounds the galaxy far beyond its bright center. In the early universe, galaxies began forming inside enormous clouds of gas, spread throughout space. These clouds were mostly made of hydrogen and helium, the simplest elements created shortly after the Big Bang. Over time, gravity slowly pulled parts of these gas clouds together. As the gas gathered and became denser, it began collapsing into smaller regions. Inside these dense areas, the first stars and star clusters started to form. As more stars appeared, they grouped together, eventually building the first galaxies. You can imagine this process like water droplets forming inside a large cloud in the sky. At first, the cloud is spread out, but gravity pulls the droplets together until larger drops appear. Some of these early gas clouds were hundreds of thousands of light years across, containing enough material to form billions of stars. Over billions of years, these young galaxies continued growing through mergers and ongoing star formation. When two galaxies orbit each other closely, gravity slowly pulls them closer over time. Eventually, the pair can merge into a single larger galaxy. This process happens very slowly and may take hundreds of millions or even billions of years to complete. As the galaxies approach, their gravity begins stretching their shapes. Long streams of stars and gas may form between them, creating glowing bridges across space. The galaxies may pass through each other several times before finally combining. Imagine two giant clouds of glitter drifting toward each other. As they mix, the glitter spreads and swirls together until both clouds become one. During this merging process, gas clouds often collide and compress, triggering huge bursts of star formation. Thousands of new stars can appear across the merging galaxies. Over time, the original shapes of both galaxies disappear, leaving behind a new, larger galaxy formed from the combined stars, gas, and dust of both systems. A galaxy is not made of stars alone. Inside every galaxy is a complex mixture of stars, gas, dust, and dark matter, all held together by gravity. Each of these ingredients plays an important role in how galaxies form and evolve. Stars are the bright objects we see shining across the galaxy. Surrounding them are vast clouds of gas, mostly hydrogen, which serve as the raw material for creating new stars. Tiny particles of cosmic dust float through this gas and help form planets and other structures. Then there is dark matter, which cannot be seen but makes up most of the galaxy's total mass. Its gravity helps hold the entire galaxy together. You can imagine a galaxy like a giant cosmic ecosystem. Stars are the visible inhabitants. Gas and dust provide the building materials for future stars and planets. And dark matter forms an invisible framework that supports the whole structure across tens of thousands of light years. Some of the faint galaxies discovered by astronomers belong to a strange category called ultra-diffuse galaxies. These galaxies are unusual because their stars are spread out over a very large area, making the galaxy extremely dim, even though it may be quite large. Instead of having a dense concentration of stars like most galaxies, ultra-diffuse galaxies look almost transparent. Their stars are scattered so widely that the galaxy can appear like a faint mist of light in space. Imagine a city where the houses are spread miles apart instead of being packed together. Even though the city might cover a huge area, it would look quiet and empty. Ultra-diffuse galaxies are similar. Some of them are tens of thousands of light years wide, comparable in size to the Milky Way. Yet, because their stars are so spread out, they can be hundreds of times dimmer, making them one of the hardest types of galaxies to detect. Not all galaxies are perfectly flat or evenly shaped. Some galaxies appear warped or bent, especially along the edges of their disks. Instead of lying in a smooth, flat plane, the outer parts of the galaxy may curve upward or downward, like a slightly twisted record. One possible reason for this warping is the influence of dark matter surrounding the galaxy. Galaxies are embedded inside massive halos of dark matter, and if the dark matter is unevenly distributed, its gravity can slowly distort the galaxy's shape. Imagine a spinning vinyl record. that begins to bend slightly at the edges. Even though the center keeps spinning normally, the outer parts start to tilt and curve. A warped galaxy can behave in a similar way. These distortions can stretch across tens of thousands of light years, affecting huge regions of the galaxy. By studying these warped shapes, astronomers can learn more about the hidden dark matter surrounding galaxies. Dwarf galaxies that orbit larger galaxies do not always remain separate forever. Over very long periods of time, the strong gravity of the larger galaxy can slowly pull the dwarf galaxy closer and closer. Eventually, the smaller galaxy may be torn apart and absorbed. As the dwarf galaxy approaches, tidal forces begin stretching it. Its stars are pulled away and spread into long streams that wrap around the larger galaxy. These stellar streams can extend hundreds of thousands of light years across space. Imagine dropping a small swirl of cream into a cup of coffee and gently stirring it. At first you can see the swirl clearly, but over time it blends completely into the drink. A dwarf galaxy merging with a larger galaxy follows a similar process. The Milky Way itself has absorbed several dwarf galaxies in the past. Their stars now travel through our galaxy, becoming permanent members of the Milky Way's vast stellar population. Between the dense filaments and clusters of the cosmic web lie enormous empty regions called cosmic voids. These voids contain very few galaxies compared to the crowded areas of the universe. Some of them stretch across hundreds of millions of light years, making them some of the largest known regions in space. If you could travel through one of these voids, the night sky would look very different. Instead of seeing many nearby galaxies, you might see only a few faint ones scattered across the darkness. To imagine a cosmic void, think about the holes inside a sponge. The sponge material forms a network around the holes, while the empty spaces inside represent the voids. In the universe, galaxies form the sponge, and the voids are the giant gaps between them. Even though these voids seem empty, they still contain small amounts of gas, dark matter, and occasionally a few isolated galaxies drifting through space. One of the most common causes of a powerful starburst is a galaxy merger. When two galaxies move close to each other or collide, their gravity begins to disturb huge clouds of gas inside both galaxies. This disturbance compresses the gas, making it much denser. When gas clouds become compressed, gravity can quickly pull the material together, causing many regions to collapse at once. These collapsing regions ignite and form large numbers of new stars almost simultaneously. You can imagine this like squeezing a sponge filled with water. When pressure is applied, the water gets forced into certain areas. In galaxies, gravity acts like that pressure, forcing gas into dense pockets where stars begin to form. During a merger, star formation can increase hundreds of times faster than normal. This sudden burst can fill the merging galaxies with bright clusters of young stars, dramatically changing their appearance across tens of thousands of light years. Not all quasars are easy to see. In some galaxies, the brilliant quasar at the center is hidden behind thick clouds of gas and dust. These dusty regions can block visible light, making the quasar difficult or even impossible to detect with ordinary telescopes. However, the energy from the quasar does not completely disappear. Instead, the dust absorbs the intense radiation and then re-emits it in other forms, especially infrared and radio waves. Astronomers can detect these signals using special telescopes designed to observe these wavelengths. Imagine a bright spotlight shining behind a thick curtain. You may not see the light directly, but the curtain glows faintly because it absorbs and releases the energy. These hidden quasars can still be incredibly powerful, sometimes shining with the energy of trillions of suns. Studying them helps astronomers understand how black holes grow even when they are buried deep inside dusty galaxies. When astronomers observe certain galaxies, they notice something remarkable. Some of them appear almost perfectly symmetrical. Their spiral arms curve smoothly around the center, forming balanced patterns that look nearly identical on both sides. This symmetry usually happens when a galaxy has experienced very few disturbances from nearby galaxies. Without strong gravitational interactions or collisions, the galaxy's rotation remains stable, allowing its structure to stay neat and orderly over long periods of time. Imagine a carefully designed pinwheel spinning smoothly in calm air. Each blade curves evenly around the center, creating a balanced shape. A symmetrical galaxy can resemble that same kind of perfect pattern, but on a scale of tens of thousands of light years. These galaxies help astronomers understand what spiral galaxies might look like when they evolve, without major collisions or gravitational disruptions, giving scientists clues about how galaxies maintain their structure across billions of years. Extremely massive stars often end their lives in one of the most powerful events in the universe, a supernova explosion. When a massive star runs out of fuel in its core, gravity causes the star to collapse inward. This collapse triggers a massive explosion that blasts the star's outer layers into space. For a short time, a single supernova can shine brighter than an entire galaxy of billions of stars. The explosion releases an enormous amount of energy and sends shock waves racing through surrounding gas clouds. To imagine this power, think of a small firecracker compared to a massive fireworks display. A supernova is like the ultimate cosmic fireworks explosion, but on a scale far beyond anything on Earth. These explosions scatter elements such as carbon, oxygen, and iron across the galaxy. The material from these blasts becomes part of new stars, planets, and even future solar systems. Among the billions of planets in the Milky Way, some may orbit their stars at just the right distance to support liquid water. This special region around a star is known as the habitable zone, sometimes called the Goldilocks zone. In this zone, temperatures are not too hot and not too cold, conditions that could allow water to remain liquid on a planet's surface. If a planet is too close to its star, the heat may boil away any water. If it is too far away, water may freeze into ice. But in the habitable zone, the balance of temperature can create stable environments similar to what we see on Earth. Imagine standing around a campfire. If you sit too close, the heat becomes unbearable. If you move too far away, you feel cold. But at the right distance, the warmth feels comfortable. Scientists believe billions of planets in our galaxy may orbit within these habitable zones, making them intriguing places to search for life. Although thick cosmic dust can block visible light, astronomers have a powerful way to see through it. Infrared telescopes detect a type of light called infrared radiation, which can pass through dust much more easily than normal visible light. This allows scientists to observe regions of galaxies that would otherwise remain hidden. For example, the center of the Milky Way is heavily obscured by dust when viewed with ordinary telescopes, but infrared observations reveal dense clusters of stars and the supermassive black hole located there. Imagine trying to look through a smoky room. With normal vision, it might be difficult to see anything clearly, but if you used special goggles designed to detect heat, you could still see objects through the smoke. Infrared telescopes work in a similar way. They allow astronomers to study hidden star-forming regions, dense dust clouds, and the cores of galaxies that are invisible in ordinary light. Even though astronomers have studied galaxies for many decades, how galaxies evolve over billions of years is still one of the biggest mysteries in astronomy. Scientists know that galaxies change over time through processes like star formation, galaxy mergers, and the influence of supermassive black holes. However, many details are still unclear. For example, researchers are still trying to understand exactly how the first galaxies formed, why some galaxies stop forming stars, and how dark matter shapes the growth of galaxies. Imagine trying to understand how a massive forest grew over thousands of years by looking at only a few photographs taken at different times. You would see changes, but the full story would still be difficult to piece together. Astronomers are working to solve these mysteries by studying galaxies at many different distances. Since distant galaxies appear as they were billions of years ago, They provide snapshots of different stages in galaxy evolution. Not all galaxies rotate at the same speed. Some turn slowly and gently, while others spin incredibly fast. In certain spiral galaxies, the outer stars can move at over 1 million kilometers per hour as they orbit the center. To picture this speed, imagine Earth traveling around the Sun. Our planet moves at about 107,000 kilometers per hour. That already feels incredibly fast. But some stars in fast-spinning galaxies move 10 times faster than Earth's orbit. This rapid spinning helps keep the galaxy's spiral shape stable. Without enough rotation, gravity would cause the galaxy to collapse inward. Astronomers also discovered something strange while studying this motion. Stars far from the center move almost as fast as those closer in, which should not happen if only visible matter existed. This unexpected speed was one of the key clues that galaxies are surrounded by huge halos of invisible dark matter. The Milky Way might feel unique because it is our home galaxy, but in reality it is just one example of a very common type of galaxy called a spiral galaxy. These galaxies are known for their beautiful spiral arms that wind outward from the center like a giant cosmic pinwheel. Astronomers have discovered billions of spiral galaxies scattered across the observable universe. Many of them look surprisingly similar to our own galaxy, with glowing arms filled with stars, gas, and dust slowly rotating around a bright center. To picture the scale, imagine every spiral galaxy as a city made of stars. If the universe were a continent, it would contain billions of these star cities, each with its own planets, nebulae, and possibly life. The Milky Way itself is about 100,000 light-years wide and contains over 100 billion stars. Yet, among the countless spiral galaxies in the universe, it is just one member of a vast cosmic population. When astronomers study how galaxies move, they notice something strange. The visible stars, gas, and dust do not contain enough gravity to hold the galaxy together. Yet galaxies stay stable and spin much faster than expected. This mystery led scientists to discover that most galaxies are surrounded by huge halos of invisible dark matter. Dark matter cannot be seen with telescopes because it does not produce or reflect light. However, its gravity is very real. It forms a massive hidden cloud around the galaxy that extends far beyond the visible stars. Imagine a small glowing island surrounded by a gigantic invisible bubble. The stars we see make up only a tiny part of the galaxy's total mass. In fact, dark matter may account for about 85% of all the matter in the universe. Without these massive dark matter halos, many galaxies would spin so fast that their stars would simply fly apart into space. Sometimes, when galaxies collide, the result is not chaos, but a beautiful cosmic ring. In certain collisions, one galaxy passes directly through the center of another. The impact sends a powerful wave of energy outward through the stars and gas, creating a giant expanding ring of stars. This process is similar to what happens when you drop a stone into a calm pond. The water ripples outward in a circular wave. In a galaxy, the ripples are waves of gas and stars moving outward through space. As the wave spreads, it compresses clouds of gas. This pressure triggers the birth of new stars, causing the ring to glow brightly. Some of these ring galaxies can be hundreds of thousands of light-years across, making them larger than the Milky Way itself. One famous example, called the Cartwheel Galaxy, looks like a glowing wheel floating in space, with bright star clusters forming along its massive ring. Galaxies may look stable in pictures, but over extremely long periods of time they can change their shape dramatically. This transformation happens slowly, often taking billions of years. Gravity from nearby galaxies, collisions, and internal motion of stars can gradually reshape a galaxy. For example, a beautiful spiral galaxy can lose its spiral arms after merging with another galaxy. Over time, the stars become more randomly arranged, forming a smoother elliptical galaxy that looks like a glowing ball of stars. Imagine a neatly spinning pinwheel slowly getting disturbed by strong winds. Eventually, the pattern becomes messy and the original shape disappears. These slow changes mean that galaxies we see today may have looked very different in the distant past. Astronomers believe many of the large elliptical galaxies we observe formed after multiple galaxy mergers over billions of years, constantly reshaping the structure of the universe. Our galaxy is not traveling through space alone. The Milky Way belongs to a small cosmic family known as the Local Group. This group contains more than 50 galaxies that are all connected by gravity and slowly moving through space together. The two largest members of this group are the Milky Way and the Andromeda Galaxy. Andromeda is actually the biggest galaxy in the group and sits about 2.5 million light-years away from us. Even though that distance sounds enormous, in cosmic terms it is considered relatively close. Most of the other members of the Local Group are dwarf galaxies, which are much smaller and contain far fewer stars. To imagine the scale, think of galaxies as cities, and the Local Group as a small region containing several nearby cities and towns. Over billions of years, gravity keeps this family together, slowly pulling its galaxies toward one another. Inside, many galaxies are enormous clouds of cold hydrogen gas, the basic building block for new stars. These clouds can stretch across tens of thousands of light years, making them some of the largest structures inside a galaxy. Hydrogen is the simplest and most common element in the universe. When large clouds of this gas begin to collapse under gravity, parts of the cloud become denser and hotter. Eventually, the pressure and temperature grow high enough to ignite nuclear fusion, creating brand new stars. You can imagine these clouds like vast cosmic nurseries where stars are born. If one of these gas clouds replaced the space around our solar system, it would extend far beyond the orbit of Pluto, many thousands of times over. Astronomers detect these hydrogen clouds using radio telescopes because the gas emits a special radio signal. Mapping these signals helps scientists understand where future generations of stars may form inside galaxies. Our galaxy may seem stable, but it is actually slowly merging with several smaller galaxies right now. These smaller companions are known as dwarf galaxies, and they orbit the Milky Way much like moons orbit a planet. Over time, the Milky Way's strong gravity pulls on these smaller galaxies, stretching them apart. Their stars begin to spread out into long streams that wrap around our galaxy. Eventually, those stars become fully mixed into the Milky Way. One well-known example is the Sagittarius dwarf galaxy, which is currently being torn apart as it orbits the Milky Way. Astronomers have discovered long streams of its stars stretching across the sky. To picture this process, imagine stirring a small swirl of colored cream into a cup of coffee. At first you can see the swirl clearly, but over time it blends completely into the drink. This slow merging process helps galaxies grow larger over billions of years. When galaxies collide or merge, the event can trigger a dramatic surge in star formation. As the galaxies interact, their enormous gravitational forces compress huge clouds of gas inside them. This pressure squeezes the gas together, causing many regions to collapse and ignite new stars almost at once. The result is often a starburst, where thousands of new stars may form in a short period of cosmic time. These regions become extremely bright because young stars are hot and energetic. Imagine two giant clouds of dust crashing together in slow motion. The impact would create dense clumps everywhere. In galaxies, those clumps can turn into new stars by the thousands. Some merging galaxies can produce stars hundreds of times faster than the Milky Way. Although the merger itself may take hundreds of millions of years, the intense starburst phase can transform the appearance of the galaxy, filling it with bright clusters of newly formed stars. One of the most amazing achievements of modern astronomy is the ability to detect galaxies that are billions of light years away from Earth. Because light takes time to travel, Observing these distant galaxies allows scientists to see what the universe looked like billions of years in the past. Some of the faintest galaxies ever discovered are so distant that their light has been traveling toward us for over 10 billion years. That means the light began its journey long before Earth even formed. To picture this, imagine turning on a flashlight and someone only seeing that light thousands of years later. In space, the distances are so enormous that light can travel across the universe for billions of years before reaching our telescopes. Powerful instruments like space telescopes can detect these faint signals, revealing tiny smudges of light that represent entire galaxies filled with billions of stars far across the universe. The long stellar bars found in some galaxies do more than just shape the galaxy's appearance. They also act like cosmic conveyor belts, helping move large amounts of gas toward the center of the galaxy. This happens because the gravity of the bar disturbs the normal circular motion of gas and dust. As the galaxy rotates, gas clouds slowly slide along the bar toward the middle. Over time, huge amounts of material can gather near the galaxy's core. This gas can feed the supermassive black hole at the center or trigger bursts of new star formation nearby. To imagine this process, think of a spiral slide in a playground funneling people toward the bottom. In a galaxy, the bar funnels gas toward the center instead. These flows can transport gas across tens of thousands of light years, gradually fueling some of the most energetic activity in a galaxy's central region. When two galaxies collide, it might sound like billions of stars crashing into each other. But surprisingly, direct star collisions are extremely rare. Even though galaxies contain huge numbers of stars, the distance between those stars is enormous. In the Milky Way, the nearest star to our Sun is about 4.2 light-years away, which is roughly 40 trillion kilometers. Because stars are spaced so far apart, when galaxies pass through each other, most stars simply move past one another without touching. A good way to imagine this is to picture two giant swarms of tiny insects flying through each other in the air. Even though there may be thousands of insects, the chances of two hitting exactly at the same moment are small. Instead of stars crashing, the real effects of galaxy collisions come from gravity, which reshapes the galaxies, pulls stars into long streams, and can trigger huge bursts of new star formation. Around some galaxies lies a vast, invisible atmosphere made of extremely hot gas, called plasma. This plasma forms a large halo surrounding the galaxy and extending far beyond the region where most of the stars are located. These halos can stretch hundreds of thousands of light years into space, sometimes even larger than the visible galaxy itself. The gas in these halos is incredibly hot, reaching temperatures of millions of degrees, which causes it to glow in X-rays that special telescopes can detect. To picture this, imagine a glowing city surrounded by a giant, nearly invisible cloud that stretches far beyond its borders. The stars are like the city lights, while the halo of plasma forms a huge outer atmosphere. These hot halos are important because they contain enormous amounts of gas that may eventually cool down and fall back into the galaxy. When that happens, the gas can help fuel future generations of star formation. Our home galaxy, the Milky Way, is filled with an astonishing number of stars. Astronomers estimate that it contains more than 100 billion stars, and some studies suggest the number could be closer to 200 billion. That means for every person on Earth, there could be more than 10 stars in our galaxy alone. These stars are spread across a disk about 100,000 light-years wide. Light itself, which travels around Earth 7 times in 1 second, would still need 100,000 years just to cross the Milky Way from one side to the other. If you tried counting the stars one by one at a rate of 1 star every second, it would take over 3,000 years just to reach 100 billion. Among these stars are many different types, from small red dwarfs to massive blue giants. Many of them likely have planets orbiting them, meaning the Milky Way could contain countless planetary systems. Not every galaxy is actively creating new stars. Some galaxies are filled almost entirely with very old stars that formed billions of years ago. These galaxies have used up or lost most of the gas needed to create new stars, so their stellar population slowly ages over time. Because older stars tend to glow with red or orange light, these galaxies often appear reddish when astronomers observe them. They are sometimes described as red and dead, meaning star formation has nearly stopped. Imagine a city where no new buildings are constructed anymore. The existing buildings remain standing, but nothing new is being added. In a similar way, these galaxies keep their old stars, but rarely produce new ones. Some of these galaxies are hundreds of thousands of light years wide and contain billions of aging stars. Studying them helps astronomers understand how galaxies change after long periods without new star formation. Over the past few decades, astronomers have carried out enormous sky surveys to map millions of galaxies across the universe. Using powerful telescopes and digital detectors, scientists scan large portions of the sky and record the position and distance of each galaxy they observe. These maps reveal that galaxies are not scattered randomly. Instead, they form a vast cosmic web made of long filaments, clusters, and empty regions called voids. To imagine this structure, picture foam bubbles or a giant three-dimensional spiderweb stretching across space. The strands of the web represent dense regions where galaxies gather, while the empty spaces between them contain very few galaxies. Some of these maps include galaxies located billions of light years away, meaning their light began traveling toward us when the universe was much younger. By mapping these structures, astronomers can study how gravity shaped the universe over billions of years of cosmic history. The earliest galaxies ever discovered are located at extraordinary distances from Earth. Many of them are more than 12 to 13 billion light years away, meaning their light has been traveling across space for almost the entire history of the universe. To understand how far that is, remember that light travels about 300,000 kilometers every second. Even moving that fast, it still takes billions of years for the light from these ancient galaxies to finally reach our telescopes. This means that when astronomers observe these galaxies, they are not seeing them as they are today. Instead, they are seeing them as they looked billions of years ago, when the universe was still very young. Imagine receiving a photograph that was sent thousands of years ago. The image would show the past, not the present. In the same way, distant galaxies act like cosmic time capsules, revealing what the early universe looked like long before Earth even existed. Our galaxy, the Milky Way, is slowly moving toward a neighboring galaxy called Andromeda. Even though Andromeda is about 2.5 million light years away, gravity is gradually pulling the two galaxies closer together. Scientists estimate they will begin merging in about 4 to 5 billion years. At first, the galaxies will pass through each other, stretching their spiral arms and creating long streams of stars across space. Over time, gravity will pull them back together again until they finally combine into one massive galaxy. Even though billions of stars are involved, direct star collisions will be extremely rare because the stars are so far apart. To imagine the scale, this event would be like two enormous clouds of glowing particles, slowly drifting together and mixing. After billions of years, the Milky Way and Andromeda will likely form a new giant galaxy, sometimes nicknamed Milkomeda. Inside many galaxies are enormous regions known as giant molecular clouds. These clouds are made mostly of hydrogen molecules along with small amounts of other gases and cosmic dust. They are among the coldest and densest regions in a galaxy, making them perfect places for new stars to form. These clouds are truly massive. Some stretch across hundreds of light years and contain enough gas to create thousands or even millions of stars. Even though they hold huge amounts of material, they appear dark in visible light because the dense dust blocks starlight. To imagine their scale, picture a dark storm cloud in Earth's sky. But instead of spanning a few kilometers, This cloud spreads across distances greater than the space between many stars. When gravity begins pulling parts of these clouds together, dense clumps form inside them. These clumps eventually collapse further, becoming the birthplaces of new stars and planetary systems across the galaxy. Even though some ultra-diffuse galaxies can be as wide as the Milky Way, they contain far fewer stars. While the Milky Way holds more than 100 billion stars, an ultra-diffuse galaxy may contain only a few billion or even less. This means their stars are spread extremely far apart. If you were standing on a planet inside one of these galaxies, the night sky might look very different. Instead of seeing thousands of bright stars like we do on Earth, the sky could appear much darker because the stars are so widely separated. Imagine a giant stadium that can hold 100,000 people, but only a few thousand are actually sitting inside. The stadium is huge, but it still feels mostly empty. Ultra-diffuse galaxies are similar in that their enormous size hides how few stars they actually contain. These galaxies continue to puzzle astronomers because their unusual structure challenges many ideas about how galaxies grow and evolve. Large galaxies are often surrounded by many smaller companions known as satellite galaxies. These smaller galaxies orbit the larger one due to gravity, similar to how moons orbit planets. Our own Milky Way has several known satellite galaxies, including the Large Magellanic Cloud and the Small Magellanic Cloud. These companions are much smaller than the Milky Way, but still contain millions or even billions of stars. Imagine a giant planet surrounded by many small moons, circling around it. In a similar way, a massive galaxy can have a family of smaller galaxies moving around it through space. Some satellite galaxies orbit at distances of tens or even hundreds of thousands of light years from their host galaxy. Over very long periods of time, gravity can slowly pull these satellites closer. Eventually, some of them may be absorbed by the larger galaxy, contributing their stars to its growth. The cosmic filaments connecting galaxy clusters are among the largest structures in the entire universe. These enormous strands of matter can stretch across hundreds of millions of light years, linking distant regions of space together. Inside these filaments are galaxies, clouds of gas, and huge amounts of invisible dark matter. Gravity along these filaments slowly pulls matter towards dense areas where galaxy clusters form and grow. To imagine their scale, picture a giant spider web stretching across a dark forest. The threads connect different parts of the web, and tiny drops of water sitting on the threads represent galaxies. In space, the same idea exists, but across distances so large that light itself takes hundreds of millions of years to travel along them. Astronomers map these filaments by observing how galaxies are arranged across the sky. These giant cosmic strands reveal how the universe organized itself into a vast network of matter over billions of years. Void galaxies are among the most isolated galaxies in the universe. They exist inside cosmic voids where there are very few neighboring galaxies nearby. In some cases, the nearest galaxy might be tens of millions of light years away, which is an enormous distance even by cosmic standards. Because of this isolation, void galaxies experience very little gravitational interaction with other galaxies. They rarely collide or merge with neighbors, and their shapes often remain relatively undisturbed for long periods of time. Imagine living in a small village placed in the middle of a vast desert, with no other towns for hundreds of miles. Void galaxies exist in a similar situation, surrounded mostly by empty space. This isolation makes them valuable for scientific study. Astronomers can observe how galaxies evolve without the usual influences of crowded environments, helping them understand what galaxies might look like if they grew quietly and undisturbed over billions of years. Quasars are some of the most brilliant objects ever discovered in the universe. Even though the bright region around a quasar may be smaller than our solar system, it can shine with the energy of hundreds of billions or even trillions of suns. This incredible brightness comes from gas and dust falling toward a supermassive black hole at the center of a galaxy. As the material spirals inward, it forms a rapidly spinning disk that becomes extremely hot. The intense heat causes the disk to glow with enormous amounts of energy across many wavelengths of light. To imagine the brightness, picture a single light bulb shining brighter than an entire city full of lights. That is similar to how a quasar can outshine the entire galaxy surrounding it. Because they are so luminous, quasars can be seen from billions of light years away, allowing astronomers to study very distant parts of the universe. The way a galaxy looks in a telescope can change dramatically depending on the angle from which we observe it. Galaxies are three-dimensional structures, so their appearance can vary depending on whether we view them from the top, the side, or somewhere in between. For example, a spiral galaxy viewed from above reveals its beautiful spiral arms swirling around the center. But if we look at the same galaxy from the side, it may appear as a thin, glowing line of stars with a bright bulge in the middle. Imagine looking at a spinning dinner plate. From above, you see the full round shape, but from the side, the plate looks like a narrow line. Galaxies behave in a similar way when viewed from different angles in space. Because of this, two galaxies that appear very different in images may actually have similar structures, simply viewed from different directions across millions or billions of light years. After the Big Bang, the universe eventually entered a long period called the Cosmic Dark Ages. During this time, there were no stars or galaxies yet shining across space. The universe was filled mostly with neutral hydrogen gas, and light could not travel freely through it. When the first galaxies and stars finally formed, they began producing intense radiation. This radiation had enough energy to strip electrons away from hydrogen atoms in the surrounding gas. This process is called reionization. You can imagine it like turning on thousands of powerful lamps in a dark, foggy room. As the lights shine, the fog begins to clear, and the room becomes visible. In a similar way, the light from early galaxies slowly transformed the universe. Over hundreds of millions of years, their radiation cleared the cosmic fog, allowing light to travel more freely across space and making the universe transparent to light. The heavy elements released by supernova explosions do not remain scattered forever. Over time, these elements mix with large clouds of gas and dust inside galaxies. When these clouds collapse to form new stars, the leftover material around the young star can gather together and form planets. Rocky planets like Earth, Mars, and Venus are made from elements such as iron, silicon, oxygen, and carbon. All of these materials were originally created inside ancient stars and later spread across the galaxy by supernova explosions. Imagine a giant recycling system in space. Old stars explode and scatter their material, and later that material becomes part of new stars, planets, and even moons. This means the rocks beneath our feet and the metals inside our planet were once forged inside long-dead stars billions of years ago. In a very real sense, planets are built from the recycled remains of ancient stellar explosions. Galaxies play a crucial role in organizing matter across the universe. Without galaxies, stars would not gather into the large structured systems we see today. Instead, stars might be scattered randomly across space, with huge empty distances between them. Galaxies act like gravitational cities of stars, where gravity pulls enormous amounts of gas, dust, and dark matter together. This concentration of material allows stars to form in large numbers and remain grouped within a stable structure. Imagine trying to build a city if all the buildings were floating miles apart from each other. It would be almost impossible for communities to form. In the same way, galaxies provide the framework that allows stars to gather and remain connected. Some galaxies contain billions or even trillions of stars, all bound together by gravity across distances of tens or hundreds of thousands of light years. Without galaxies, the universe would be far more scattered and far less organized. Some galaxies that appear faint or nearly invisible light, can still shine strongly in radio wavelengths. Radio waves are a form of light with much longer wavelengths than the light our eyes can see. Because of this, radio waves can pass through dust clouds that block visible light. When astronomers use large radio telescopes, these hidden galaxies often reveal enormous structures of glowing gas and energetic particles. In some cases, powerful jets from the galaxy's central black hole produce huge regions that emit strong radio signals. Imagine trying to see a building through thick fog. Your eyes may struggle to see it clearly, but if you used special equipment that could detect heat or radio signals, the building might appear much more clearly. Some radio-emitting structures can stretch millions of light years across space, far larger than the visible galaxy itself. Studying these radio signals helps astronomers explore energetic processes happening deep inside galaxies. Not all galaxies grow by merging with others. Some galaxies increase their size mainly through steady star formation over long periods of time. In these galaxies, large clouds of gas slowly collapse and create new stars year after year. This process may seem slow, but over millions or billions of years, it can dramatically increase the number of stars in a galaxy. Even forming just a few stars each year, like the Milky Way does, eventually adds up to millions of new stars over time. Imagine planting a tree every year in an empty field. At first, the change might seem small, but after hundreds or thousands of years, the field would grow into a large forest. Galaxies can grow in a similar gradual way. As new stars form, they add light, energy, and sometimes new planetary systems. This steady growth helps shape the galaxy's structure across tens of thousands of light years.